Hey, good morning, everyone. Just going to back up a few slides just so we remember what we're looking at here. Okay, so yesterday we talked about some additional simulations that had been performed, and that included some look at low and high PDO scenarios. This morning, let's talk about some objectives and then updates to the operating model, as well as exceptional circumstances.
Can I ask a question about PDO before we?
Sure.
I mean, have you ever tried simulations where you were looking at potential lag effects of PDO, not necessarily on biomass or recruitment in the same year, but some year hence or some sort of lag effects?
Yeah, we haven't been investigating in that much detail on this. Basically, what I've done is taken it as these regimes, which are long periods of time as well. And so, yeah, that's something we could certainly do is look at these lag effects. But I think Ian has looked at is the PDO, the actual yearly value, the annual value of the PDO, a good predictor of recruitment. Have you tested any lag effects in that look? Or
looked at a running average, annual values, the regimes.
Right. And nothing.
We didn't find anything that was a better predictor of recruitment than just using the general regimes. None of the ways we looked at the PDO did a better job of predicting individual recruitments. Part of the problem, I think, is that the PDO is really a composite of a bunch of different factors influencing the North Pacific. It in itself is not a mechanism, but it's related to current patterns and it's related to temperature and it's related to other things. So we're using it as a proxy, but it's not the process that's driving. It's just a proxy that's correlated with that process at best.
But the process has a relative value. Those points that you showed yesterday, they weren't just green or red. There was some amplitude difference, right, in across years and things like that. So you have to be able to estimate that based on some properties, right?
Yeah, but those values didn't predict recruitment better than just using the regime as a tuning to tune the average recruitment.
So it's just a multiplier on recruitment.
It's a 0-1. So in the assessment, we estimate a coefficient, and then the regime is just a 0-1. So in periods when it's in a positive regime, it's the coefficient. It's e to the coefficient times mean log recruitment for the stock recruitment function.
And that's not to say there's not something else that we can relate, another environmental variable that might relate more specifically to recruitment or have some lag on recruitment or something like that. We just haven't investigated that yet. And I think the research branch here is been doing a lot of research to look at not only the effects of the environment on the Pacific halibut population, but other aspects as well, habitat and some other things. So it's part of our research plan, I think, just not specifically identified that we want to look at anything and its relation to recruitment and any environmental variables, but something we could do. So. Okay, so related to the objectives for the MSE and the goals and objectives and performance metrics. What is that going on over there?
You hover over it, it goes away. It's doing that to me too.
There we go. Yeah, so objectives. So the one thing the SRB has said over a number of meetings is there are a lot of objectives. And how do you actually winnow these down to a set of objectives that you can present and actually look at and make decisions on? So I think in the MSE Explorer that we have online to examine MSE results, there might be 200 different performance metrics there. And that's overwhelming. That's why we created the Explorer. The MSAB, working with the MSAB, we came up with what we call primary objectives, and that was like 15 or so different objectives, coast-wide and area-specific, the commission really wanted to narrow these down even further. And working with the commission, we've narrowed it down to 4 priority coastwide objectives. So we're calling these priority objectives. And the commission has actually presented these in, or labeled these in order of importance. So the top 2 objectives are more related to population size, and then the last 2 are more related to yield specific. The top 2 are long-term objectives, maintaining the spawning biomass above 20%, and then maintaining the spawning biomass above 36%, which is a proxy for MSY that we determined a number of years ago. And then the last 2 are just more general objectives without any real specifics of whether they pass or fail, but they're objectives and performance metrics there to look at how the different management procedures are affecting these performance metrics. So a couple of things in red that are important to highlight in these. First of all, we noticed yesterday I had a pass fail in one of the tables I showed. And so we're starting to report maintaining the population above 20% as a pass or fail with this tolerance of 0.05 or 5%. So if less than 5% of the simulations fall below 20%, that's a pass. The second objective there is one that relates to this target concept. And we've been thinking a lot about what is a target versus a threshold. And if we had defined this originally as a target, but we were treating it as a threshold, meaning we defined it as, oh yeah, this is our target biomass, 36% of B0. But then when we were evaluating management procedures, we were saying, oh yeah, it's okay if we're above that target. So there's some confusion among stakeholders in the commission. So we really wanted to clarify it this time, and instead of calling it a target, call it a threshold, so that we don't have to try to meet that target. We don't have to find a management procedure that takes us to that biomass and is below and above 50% of the time. If we're above it 50% or more of the time, that's okay. We fall below it more than 50% of the time, that's not okay. And this helps because we have these other priority objectives of providing directed fishing yield and variability. If we have a target, those objectives sort of are much watered down in that you're really defining the problem by saying you want this fishing intensity to get to that target. You're going to increase variability in the yield, might maximize yield, but at the cost of other things. So we wanted this flexibility. So we've called that a threshold, and I think that's helped a lot of people, and a lot of discussion with the MSAB. Some want this reported as a pass-fail, and some want the actual number. And I think the actual number there is useful as well. Did it fall below 36%, 20% of the time, 40% of the time? I think that's something that's useful to see in the results. So we'll report both of them. I think Kim mentioned yesterday, why not report the number and then color it red or green or something like that, that might indicate pass or fail. So we'll figure out ways to do that and communicate this the best. And then the last 2 are just simply performance metrics, just looking at those values, and then we can evaluate the trade-offs between the management procedures. So even with 4 objectives, there's still a lot to look at, and this has really helped the commission. So it was a good process to talk with the commission about this and then specify exactly what they want reported. But I don't want to forget about all of the other objectives and the work that the MSAB has done in defining things that are important to stakeholders, especially at the area level. So this first one, keeping the female spawning biomass above a limit and conserving spatial population structure, is something we worked with the SRB years ago. And that was just maintaining some presence of fish across the entire range, across the coastwide range. And we don't know what the importance of these different regions are, so we want something there. And originally we defined this as just maintaining some minimum proportion of spawning biomass in each region. And those proportions are defined there, which was an arbitrary initial look that I had, and I'll explain exactly how that was done on the next slide. And so that's the sort of area specific conservation objective. And I want to dive into that conserving spatial stock structure a little bit more. And so here's that objective again on the top with the percentages that were arbitrarily defined. And this is how those percentages were defined. We looked at the proportion of, this is actually 032 WPB from FIS in each of the regions. That's what's being plotted there. And then we just decided on some percentages that are below what had been observed in the past. So we're using 032 WPB as a proxy for spawning biomass. And we're looking at it historically. And then we just define a threshold that's below what has been observed. And so you can see on the right there in 4B, that red line is right below what has been observed in the past at 2%. What we found when we started running management procedures is that no management procedure could meet the objective for region 4B. It always fell below, all of them went below 2% of the spawning biomass coastwide, more than 5% of the time. And so there was some probability of going below that. So we did a lot of investigation and we said, yeah, it's just, even without fishing, there was some, it looked like there was potentially a probability of going below that threshold in these simulations. It's not showing up here though. So what we did is using those same PDO low and high runs, we looked at the proportion of spawning biomass from the modeling simulations in each of the different regions. And now I've split it out unfished, both in the cyclical PDO as well as always low or always high, and then a fished at a 43% SPR at both in low and high as well. And what you can see in region 4B is that when you're not fishing, it does not drop below that threshold. Though I believe in past simulation, past operating model, it had for some reason. Why? But what you can see now is that when you have a cyclical PDO, it can fall below that threshold for fishing, but it's only when the PDO is high. So that's related to somehow, for some reason, the distribution of recruitment isn't good there. The movement, I don't think the movement out of 4B is related to the PDO because that's a fixed movement rate. So it must be how much recruitment gets out to 4B in this low versus high PDO periods. But really what the idea here is like, is this a good objective? We've never met it with a management procedure. We really got to think about this objective. Here's some results that show sort of why something in the modeling is saying, why there. We don't actually know the mechanism. That's what's really causing the population out in 4B. As Ian mentioned yesterday, it has very different demographics than the rest of the coastwide. So it's a different area. It's somewhat connected. We've seen through tagging data. We don't want to ignore it. But what is a good objective for us looking at conserving spatial structure?
Before you move on, it looks like you can do it though in the unfished scenario there, right?
Right. Yeah.
So presumably there are allocation rules that could get you there. That's something that the MSET didn't want you to investigate as a possibility.
That is something we investigated a few years ago, I think like 2020. We were investigating different allocation rules, and one way of doing that was the relative harvest rates. And I think I might have a slide related to that as well. But that is certainly where we're thinking. It's like we might be able to find a management procedure that does reduce fishing pressure out there and maintain some sort of spawning biomass out there. But under the 5, and remember, this is under the 5 distribution procedures that we integrated over, which all of them have a relative fishing level in 4B of 0.75 relative to the other areas on the coast. So still reducing the fishing effort out there, but maybe not enough. can't remember if I have in the presentation. I know in the document I brought up some analysis we did, yield per recruit analysis, that showed 4B is definitely a different area, and perhaps having the relative fishing area is a better option out there. So that is something, I can't remember if we ran that as a management procedure in the past or not. There's evidence, the yield per recruit suggests, yeah, relative fishing effort in 4B might be lower. And then maybe we need it. Oh, yeah, so that's the third bullet point here. So the ideas, the ideas we have about, this stock distribution related objective are just simply redefine the objective. Redefine it as 1% or increase the tolerance. That's the first two bullet points. The third bullet point, as you said, is there a management procedure that could meet this objective? And that could perhaps reducing the relative harvest rate out there. And there's work that we've done that suggests that could be a reasonable way forward. And then a fourth option is really just, is percent spawning biomass really how we should think about this objective? Or is there some other way of conserving spawning biomass out there? If there's just some minimum number of fish out in each region or something like that, that we might want to consider. How to define that might be a challenge as well.
This is an additional variation on the second bullet there, which is to define different tolerances for the high and low states. So I see one of those at the time.
That's right.
Retrospectively.
Right. Yeah.
Can you go back to your previous? So the values that are there now look like they're kind of ineffective as an objective, but they're not going to force any real action.
Right.
They're kind of ensured to be irrelevant,
Yeah.
given the way they are now. I mean, if you, like, what percentage of the unfished do those represent? Is that 5%?
What do you mean?
Like for region 2, for example. So it's 5% is the threshold.
Yeah.
Which the unfished with both is like 25%. So it's 20% the unfished percent.
Yeah, I see what you're saying. You're trying to get it.
That's pretty low.
Mhm. So yeah, you're thinking of in a more regional sense and how much are you fishing down a region?
Yeah, and like if you go back again to your previous one of the actual historical distributions there.
Yeah.
I mean, I'm just looking at region 2 because it's fluctuates quite a bit. 15 to 25% is a pretty big difference. And if it was down anywhere near 10, 5%, just be howls of outrage, like there'd be a full-on crisis
Yeah.
well before you got to 5%.
Yeah, true. And those red lines, these percentages were really, I think, we defined this objective, didn't have the specifics, the measurable options in it. And it was something, I think, last minute where we just had to put in some numbers. And I said, these are reasonable numbers. And, that's the problem when you do that, they sort of stick and then it's hard to change them. And so now we really want to think about this objective. Is this even a good objective framed this way? Is there a better way to frame this objective? If this is a good objective to frame, what are reasonable values? How do we come up with those?
It's also, we don't have much historical perspective here. So the survey only goes back to the early 90s. We think that the stock was probably much lower in some of these regions in the 70s and perhaps even back in the 20s and 30s. So we were reluctant to push these right up below what we've seen only in the last few decades, because the idea of this was to sort of look at the historical envelope, and we have some idea that the stock was probably lower, particularly in region 2 and 3 historically, than this more recent period that we've actually measured. Perhaps not out in 4B. It's possible that was less exploited historically.
Right. but two was, early on, that was where all the exploitation was occurring. And
Yeah, it could
who
be
knows
much
what
bigger
that
than
was
it
in
is.
the 30s or 40s.
Are the problem, portions constrained to some to 0.5? Is that
No,
directly?
no, they're just coincidence.
Could be something where it's, the obvious choices are some percentage of the unfished, so that it's always scaled to your operating model set, you're not picking something somewhat arbitrarily. I mean, that's the Canadian approach to reps. It's just like picking averages and doing these arbitrary things that bite people.
Mhm. So potentially scaling it to some unfished by region.
Yeah, that way they would all be the same. 50% of the unfished
Mhm.
one, and then you can kind of see where they lie on there. And because like what you're saying, you were already kind of implying that, well, maybe we need to do something about 4B. And so you're implying that the threshold should actually be somewhere in that. You should already be in there.
Mhm.
You're maybe some action needs to be taken.
That's probably a better way of thinking about it, because it's not the proportions that matter exactly, right? I mean, you can imagine gangbusters recruitment in region 3 would drop the proportion in region
Yeah.
4B. That's not a problem in itself in region 4B.
Yeah.
So you don't want to get too low in region 4B.
Right. And and I think that's part of what happens here too. It's not that there's lack of biomass. There's just relative to the other areas, there's much less. Yeah,
I mean, you can only tell by looking at the absolute, the estimate of the absolute biomass.
Yeah, I'm agreeing with you to go back to that, because that's really what we care about.
Yeah.
Yeah, I mean, a management procedure that reduced biomass in 3, for example, would have a high risk of triggering this criterion for region 4B.
Yeah.
Pretty good risk.
Right. Yeah, so we'll definitely be thinking about this over the summer. If you have any insights. Because I don't want to lose this type of objective as well. I think maintaining that spatial structure in some way is really important, just given our lack of understanding about the importance of these regions to sustainability.
But do you also have regional catch objectives?
Yes. The next one. Yeah. So I just wanted to finish up the objectives, reminding that the MSAP has also come up with area specific. So these are specific to regulatory area, which region is made up of regulatory areas. And so we do have quite a few in our evaluations. We really haven't seen real specific analysis of the trade-offs between all of these, but they're certainly in everybody's mind on these. So we've defined them, but we've presented them, but I think a lot of people are still thinking on the coast-wide objective. So they're pretty general, and they're just reported as performance metrics. So we don't really have any specifically measurable yield objectives by regulatory area that would then sort of replace that conserving spatial structure.
They're going to be highly correlated.
Yep.
So, and specifying something like a minimum TCUI for each area would be much easier to do. Something you can measure and things where the spatial structure will take care of itself. For those.
Yeah, if you have the fish in the area for the opportunity, then that means you have the fish in the area conserving spatial structure. It's been challenging to specify specific numbers.
Nobody wants to put their cards on the table.
Yeah,
And they use optimize.
Yeah, exactly. So these objectives you know, I don't mind them being a little less measurable, but I think something needs to be measurable that allows us to evaluate the management procedure and its effects spatially on the stock. Yeah, there's other objectives that popped up, like opportunity in the regulatory area for fishing, you know, things like that. It's like, what does that mean? We want fish out there. Okay, what does that mean? You know, and you start going down that route, you start unable to answer those why questions, sort of stuff. But that is an interesting point. It's conserves spatial structure through yield techniques as well. That's the last slide of objectives. Would you like to move on to operate? Okay. Yep.
I was wondering if there's one particular objective that you could force every procedure to meet. Because when you show your performance, every procedure, you know, against 4 objectives, everyone's different.
Mm-hmm.
So for example, when you know, you could have one procedure pass objective 1 at 0.01, and another one pass at 0.049,
Right. Yeah.
and that seemingly small difference could have a huge difference in catch. If they were both forced to be 0.05, then you would actually see the difference would be made up, and then you would see a catch difference, right?
So you're saying if both management procedures are forced on objective 1 to be 0.05, like you adjust
Yeah.
fishing mortality or something, so
Whatever
that
it is in the procedure, yeah. Because one procedure is being more conservative than the other,
yeah.
but at the same time, you're trying to maximize yield. So you're not actually maximizing. Like that, if that procedure that comes in at 0.01 was tuned to be up to 0.05, then you can see whether it's actually maximizing yield.
In terms of the other aspects of the management procedure.
It's just a way of reducing the dimensionality. I've had this come up when in our sablefish example, we initially were saying, oh yeah, well this procedure is better than that one, but you know, somebody like Brian Moe says, yeah, but what if you forced, you know, what if you weren't so conservative? You don't have to be.
Right. Would being conservative though come out in the maximization of yield for the less
No.
conservative one?
Well, go ahead, sorry.
No, where the less conservative one may result in less yield, or I mean, the more conservative one would result in less yield.
It would.
And so if it passed, say, the first 2, then you would find the better performing management procedure in the third objective as the one that actually maximized the yield.
But there's another procedure out there
That could
that could do better,
right.
in yield for the exact same performance against objective 1.
So yeah, I see what you're saying. Yeah, no. So you're tuning it to still pass those first 2, but pass them in a similar way, and then really see how they come out in terms of yield.
I don't know if you could do it for both, but certainly you could do it for 1.
Yeah.
It'd be worth the experiment, right? Just to see.
It would be, and that would take. So I could do this using the SPR value or something like that, efficient intensity.
Exactly, yeah.
And that would then remove that sort of element from the table of like, oh, here's 40%, here's 43%, whatever you look at. Yeah. Reduce the dimensionality.
You might see some actual differences coming out in the catch. For example, between 1, 2, 3 year assessment cycles rather than having assessment, of each other,
Yeah.
but they're actually differing a lot from objective one.
It's, that, yeah, the communication of that would take a little bit of work. Because a lot of stakeholders and managers, commissioners are focused in on what the SPR value is, like 43%, moving away from that SPR value. It's like, they think, well, what does that mean? I like 43% for whatever reason.
Well, do you like catching?
I know, yeah.
Do you like money or do you like
So-
43%?
So yeah, but there is a lot of interest in moving away, with the new assessment. They're like, well, is 43% the right value? So this may be the opportunity to start going down that route.
Determining what is right.
What is right,
Yeah.
yeah. And I think when we, especially if we get to the point of examining distribution procedures, then, really, that would be a really useful way to look at how different distribution procedures perform without this additional axis of fishing intensity sort of messing things up.
Yeah, I could see that, being another issue, right? It's like, well, our area is not getting as much fish, but you're being super conservative over there, and not, we're being too conservative. And then I think there would be some trickle down into the spatial.
So require a lot of discussion to figure out which of those reference points is which of those objectives is the critical one.
Yeah, but more obvious in a rebuilding situation where you actually have something you need to rebuild to.
Right.
That's
Right.
the more obvious one.
Yeah. And it's to me, to actually, yeah. Objective 1.1 with the control role, the 30-20 control role, you rarely ever get the biomass low enough. So I think every management procedure might be like 1 out of 1,000 simulations actually goes below that level.
You probably really have to crank down.
You'd have to remove the control role.
You have to-
Yeah, because it's 30-20. By the time you get to 20%, you have no fishing. There's just very little. That it rarely even goes below 25% because you're ramping down that fishing so fast. But yeah, I think that would be an interesting experiment to show if I want to get back and show again the effect of the control rule. Objective 2 is where we've been talking about this threshold, but this is the issue. I like the idea of making the management procedures perform at the same level, say with objective 2. We find fishing values that bring them both to 38% of relative spawning biomass, say, and they're both at 38%. So they're performing equally in that sense, or have some same probability of dropping below 36%. And then looking at the performance of the yield and the average annual variability. But what we've found, I think we might be able to do it. I'm just thinking about how it interacts with the 2 last yield objectives. And that might be a little bit more complicated because we've been trading off total yield with variability, and variability has obviously been very important with history. And so that's why the fishing intensity has actually been back down, been reduced to say 43% rather than I think a 32 or like a 38% SPR would actually meet the target, 36% of the spawning biomass. But they want it back down because of variability. So
There's other ways to control variability in yield too.
Yeah.
Besides that.
yeah, thinking about this. Well,
I mean, there are advantages
Yeah.
to using objective 2 instead because, 0.5 is a more stable thing to hit than 0.05 probably.
yeah.
But a lot
That
more
kind of
ways to get 0.5.
Well, exactly. The issue there, though, is getting to 36% with 0.5 probability, so being above and below 36% equally, is just a showstopper for variability in the yield. The variability goes so high that no stakeholder would be willing to accept that. And that's why we've gone away from the target concept here. It's because once we introduce that target, then our SPR is 38% or whatever it is. And that's just too much variability.
You have to,
And so we have to
depends how you
back up.
measure that too. Like, can it be, can you pick a point in time and say, okay, all trajectories, the median trajectory needs to go through that point.
Right.
So that would allow it to get there lots of different ways.
And we've thought about introducing constraints and different things on there. And all that a constraint does is it makes your effective SPR, reduces the effective fishing intensity. So even though your target might be 38%, you're effectively fishing at 43%. So I feel like that's almost like sweeping some things under the rug, It works, but you have to be honest in what you're really fishing, what your real fishing intensity is. But I do like the idea of sort of trying to bring all the MPs you're examining onto an equal ground so you can really look at how they affect the yield. Give that some thought and see how we can do that. All right. But yeah, I just want to point out there that, the concept of a target having a target objective and trying to make them always be on average 36% of relative swine biomass can put us in too small of a box without being able to adjust it. So,
I mean, that's why objective one is possibly the owning group, just it's because it's a small percentage anyway. I don't know what it's going to turn out to be, but I'd be curious to see what the range of outcomes would be.
okay. Change the control rule in some way that we can actually get to that. That's fine. Okay, yeah. Okay, thanks for that. Are we good to move on to then the operating model? Excellent. So at the 99th annual meeting last January, we presented the stock assessment, which now estimates natural mortality in 3 of the 4 models in the ensemble. And that changed the outcome of what the sustainable fishing level is, or the perception of that sustainable fishing level, because you have one with much higher natural mortality. So and that's a bit of a paradigm shift in the stock assessment. The operating model was tuned to the previous stock assessment, and the assumptions in that operating model previously were there's 4 different models. 2 of them were sort of related to the long coastwide and long areas of stock assessment models, and had values at M taken from those. And then the 2 other operating models had natural mortality values taken from the 2 short ones, which was 0.15 for females. So now those operating models are out of date and out of sync with the stock assessment. So a lot of talking between Ian and myself, we thought, the stock assessment's on this 3-year cycle where there's a full stock assessment every 3rd year. It might be useful to bring the operating model onto a same cycle where you get a full stock assessment. There could be some big changes. There may not, maybe, but maybe we should be reconditioning the operating model after that full stock assessment is done, as sort of just making sure things are in alignment. We don't get too out of alignment. So that's what we thought this year. So previous, we had the operating model. Now, currently, I've been reconditioning them. I'm not completely done, but I'm almost done with that. And we're doing a similar concept of just sort of linking it with the 4 different models within the ensemble. So those are the long and short AAF and the long and short coastwide models. And really the goal here is to just have some structural uncertainty across these operating
seems like there's a real risk here that you could be constantly chasing your tail. But the assessment, chasing the moving target.
It is, and the way that I see it, at least right now, is the assessment is that sort of real look at all of the data, all the current data, and our understanding, and it's that real. It's our best estimate of how the population of Pacific halibut has been forming or behaving. It's our best estimates of that, and because the operating model being area specific, it's really difficult to fit to the data in sort of a fitting optimization algorithm. As Ian, when I first joined IPHC, he had been doing a lot of work on that, and we found that it's just too complex. There's a lot of confounding of parameters, things like that. That, you know, having this understanding from the stock assessment to go into the conditioning process is really helpful in that sense of supplying information to the conditioning of the operating model. But I do agree with you, we could get into that cycle of chasing your tail, especially if we use the operating model for simulation of testing the stock assessment. We do want to be careful.
Yeah. It might not even improve understanding of the performance of management procedures, right? How much does reconditioning the operating model change your conclusions about performance of management procedures? Because that's the ultimate goal.
Right, right.
There's a communication element too, though, which is anytime we make a change, the first question is always, well, how does this affect the MSC? How does this affect other stuff? And so in some regards, it's just easier, even if we know that it's not going to change things a lot in terms of ranking of relative procedures, it's easier to be able to say, yeah, the MSC and the assessment are consistent.
That was the first question after Ian presented at the annual meeting. I started getting emails like, what does this mean for SPR 43%? Okay, let's test it out.
I mean, if this is happening on a 3-year cycle, maybe not a big deal, but if every year you're reach changing and trying to follow the changes, that's just it.
You don't want to do it every year, like Pacific Herring and DFO got into doing that. Retesting the management procedure every year. It's like, you're making way too much work out of this.
Yep.
But I don't see a problem like reconditioning the operating models every few years. See a problem with that.
And that's why we're proposing sort of this cycle, is to not get into that trap of that's a lot of work, but
And
also having that stability.
And there's not, you may not even need to change your management procedure.
Mhm.
Like when you finally get one, like I would say, you might want to check it.
Yep.
Every few years, but do you need to constantly change it?
No, and yeah, I wouldn't. I would imagine it would be that sort of process if, you know, we have a management procedure in place. Some new information comes in, say fecundity changes the stock assessment or something. Okay, we put that into the operating as well, that new knowledge, recondition it, and just make sure that the management procedure performs well.
Yep.
As, you know, and then investigate anything else. And that will actually have, you know, Marine Stewardship Council certification and all those things. We'll probably want to see that anyways. You know. Okay, so in this process right now, conditioning the operating models, I actually have 3 of the 4 done as of this morning, and the 4th one's nearly there. But what the process of doing that is, you know, a lot of parameters are taken from the associated assessment model, and so, you know, like natural mortality, I'm not trying to estimate that in this area-specific operating model. It's just too difficult. To do that. So we take a lot of parameters from the assessment model, things like even like selectivity and recruitment deviations. And what we're focusing on in the conditioning process is what are estimates of movement from area 4 to 3 and then 3 to 2. Other movement is fixed at what we have observed through tagging data. It also estimates the scale of the population. Because I'm starting the operating model in 1958, which actually helps. And we had a discussion about this a year or two ago. There's this sort of bottleneck in the late 1920s or 30s where the population went really low, and the operating model was really getting affected by that. That bottleneck was affecting the estimates at the end. By just removing that and starting in 1958, really freed up that operating model to estimate movement, which seemed much more robust. But because I'm starting in 1958, there was a lot of fishing mortality occurring before that. So I estimate the scale R0 as well as the initial fishing mortality to scale the start of that operating. That seems to have worked pretty well. But then the focus is on what proportion of the coastwide recruitment goes to each region and what do the movement parameters look like. That's where the hard part of the conditioning is, for a number of reasons. One, both of those related to the PDO. So distribution of recruitment differs, and the movement also differs by the regime of the PDO. But if you think about it, and we talked about a little bit yesterday, how you distribute the recruitment is going to affect how they have to move. So there's a confounding there. So really, honestly, this model has parameters that are confounded with each other and just cannot be estimated freely. So there has to be a lot of tuning in this process as well. I do use likelihood to find the best fits in these parameters, but I have to really guide that likelihood. It can go off the rails really easily. And I've found multiple similar solutions that explain the data similarly, but have very different recruitment parameterizations. And so I have to do a little bit by eye to say, look, are we exceeding some things like 80% of the population at age 4 is moving from this area to another? Doesn't seem reasonable given our tagging observations as well.
So you're not using an optimizer, you're just kind of enforcing it? Grid
I am
search
using
kind
an
of thing, or-
optimizer, but I have to start out with like a grid search, which is just, the way I start out is just moving some parameters around, and I have a lot of bounds on like movement rates can't go above 0.5 or something like that. And so I start in what I think are decent places, and then I use an optimizer and fits to the spawning biomass from the stock assessment, fits to distribution from the survey, the stock distribution percentages. There were some figures of those in the document. Fits to the index data in each region, individual region. And then I just add up all those likelihood fits, try to optimize the time. But I can get it. Well, this is, we talked about this a couple of years ago, and I'm using Optimum R because I wrote this in C++ without ADMB or all that. Hindsight, maybe a mistake, but
Everybody said, everybody who writes a model in C++.
yeah, I mean,
Ultimately comes back and says, I should have just done it.
yeah, I mean, the simulation process is the longer part of the process, so it's fast in that sense. And all the derivative calculations and ADMB can slow that down, but yeah, for when I'm conditioning the models, I'm like sort of.
So are you using
But I use
one of the-
Optim.
one of the Notre Dame or something like that? You're using a derivative based one, or?
I don't have, yeah, I'm not using a derivative based one. I forget, we talked about this a while ago, and you actually provided some really good direction on how to use Optim for doing this, but it's super slow. And, it's just, but it's a matter of getting those models conditioned, and then you're done, right? You don't have to do it anymore.
Yeah, I mean, you don't have tons of deviation.
Yeah.
Stuff.
Yeah, so it does it, and it can estimate a Hessian after the optimization's done. And so I get some idea of uncertainty in these parameters. And then I take that uncertainty as well as uncertainty in all the parameters I brought from the assessment and those two covariance matrices. And then I use that to sample to bootstrap from this multivariate normal distribution. And then I bootstrap all these individual parameters and create trajectories, make sure none of them are going extinct, all those sorts of things. And then that's how I create you'll see some plots in a second. Final operating model. So it's a process that is, I wouldn't say it's statistically rigorous in likelihoods and fitting and all of that. But I think if we went down that road of statistically rigorous, as Ian had done in 2016, we find that this model with different regions is just really unstable get you to places. I think you looked at it and it just wasn't giving you an answer that was reasonable.
It's that confounding between recruitment distribution, recruitment scale, and movement rates. It's just really hard to disentangle.
Could you essentially formalize what you're doing by just putting very involved priors on it?
It is, that is similar to what I'm doing. I probably haven't put in enough priors on it. So yeah, it is a bit subjective and while these priors are up here in my head rather than.
It'd just be a way of like making that more
Yeah.
explicit that yes, I'm doing these constraints. This is what I'm assuming that, like you say, a value of 0.8 is highly unlikely for probability.
Yeah, that's a good point, is I should.
Maybe try using your proportion of recruits to each region is actually linked to PDO.
Yep.
So you're estimating the parameters of that relationship.
Yes. So it's, what it's using a logistic, something where 4 regions, you could estimate 3 parameters to get the proportions. And it's doing it in a way that allows the work counts on proportions, but it's doing a logistics, so they're continuous. And it has a PDO coefficients as well. But yeah, when you start trying to submit the Hessian, you can see that that these things are just really not well defined. So, and that's why when I explain it to others, I explain it as conditioning, not fitting to the model. So let's see. So here is the example. What I've changed my naming convention. I'm just calling them OM 1, 2, 3, and 4.
Yeah, you just on the
Yeah.
last topic. That is one of the reasons why you may not want to use a formal stock assessment in your management procedure. Because then you'd be taking your good stock assessment, trying to fit it to something that is not as good as that stock assessment. And you're gonna, you know what I mean?
Oh,
You're gonna find out that
in
your stock
the-
assessment doesn't work that
In the
well.
simulations.
Yeah.
Yeah, we've been struggling with the stock, running a stock assessment. These simulations take so much time
Mhm.
that, and we haven't been able to mimic it very well, even.
And you're gonna be stuck, okay, which one do we actually want to use? And it's just a waste of time because
So instead, you just take the true biomass nets and stock assessment error.
That's what we're currently
Well,
doing. We have a bivariate way of doing that with correlation, autocorrelation as well.
which, why not? And that's why we've been kind of pushing the issue of using an empirical, because then you don't even forget about trying to mimic a stock assessment. Just, how to simulate the FIS pretty well. So just draw, make your rule.
And the stock assessment still has its use in determining status and, understanding of the population, fitting the data and all of that.
Just don't have to do it every year.
But yeah, exactly. So and that's still a topic the commission is interested in, is investigating multi-year management procedures. And we really like the idea of this triennial one to sort of link it with the full stock assessment process as well.
The results we showed yesterday was,
Yeah.
depending on how much you weight the different objectives.
Yeah.
But, it wasn't like it goes off the rails.
Yeah.
Because the stock assessment's really just,
It's following the survey.
stock assessment's really just following a survey trend anyway. It's just a fancy smoother for the survey trend. So
I think, a big part of it too is just everyone involved in the process becoming comfortable with not seeing the stock assessment. Seeing a big change in the survey sometimes says, and we'll talk about this as the next topic, when some see a big change in the survey, they want to sort of ground truth that with other things, the stock assessment or whatever it is. And
But
so-
the assessment estimated them that year, and things actually went the opposite of what they
Exactly.
thought.
So,
It's like,
yeah.
all right, just give them less to think about.
Yeah, well, they follow, yeah, so this last decision, they followed the survey trend anyways, right? Even though there was a stock assessment for decision making.
Interesting.
Yes.
They didn't want to change the TCU.
Well, there was just concern about all the indices, still in decline and things like that. But all of a sudden there's a new stock assessment that says we can take more quota that's confusing. And right. Ian and I had hours of discussion trying to figure this out ourselves.
There were also some unstated fishery objectives as well, which is that people in certain areas were not as satisfied with their catch rate. And so even though there was potentially more yield available, they didn't want to see lower fishery performance next year because they would have to fish harder on a smaller stock to catch the same amount of fish, and they weren't happy with that choice.
You end up losing money.
Right. But we don't have that codified anywhere. So here now we have decisions based on objectives that aren't really part of what we're testing. And that's a tough one.
That is a tough one. And I mean, that's supposed to be one of the benefits of the whole MSC process, right? Is getting out those unstated objectives and making them formal.
But yeah, and that's what this part of the process is about, right? That these things come out, and you have to recognize this is what's happening, that there's an unstated objective. And work to, if you can, deal with it. Like I was thinking, I don't know how much effort you put into it, but certainly trying to forecast fishery CPV, model fishery CPV even reasonably well based on the operating model and stuff that it might get their attention because that's going to move around.
Right. That's something we've been thinking about. It's challenging and something that we could work on in the future.
I hear all the time when the association about yellow eye stuff. We have these. I'm just talking about yellow eye catch rates. It's all about catch rate.
Right.
Well, and that's the challenge with trying to forecast fishery CPUE is that for the last few years in BC, it's affected by things like yellow eye quota, which are not really part of our system. So they're experiencing, and it's actually getting better in the last couple of years, but in the last 5 to 6 years, they've experienced a decrease in CPUE. And I did some work with Robin Forrest showing that part of that is probably attributable to spatial shifts in the footprint away from these yellow eye hotspots to areas that actually have lower halibut catch rates. So we can't really predict that because that's exogenous to our models, but it's a real phenomenon. It's brought up at lots of meetings. And when we looked at the spatial fishery data, we found that was definitely evidence that was going on. They were moving out of those yellow eye hotspots.
But that's a good point about the stock assessment. I think the SRB made a statement 20 or 21. It might have been 20, SRB 20 about that exactly. Don't try to simulate the stock assessment. I can pull it back. Yeah. Okay, so just a couple of little figures of the outputs. What this is showing is the red line and the red shaded area is the prediction and the uncertainty from the stock assessment. The blue dashed line is sort of the process of me conditioning the operating model. And that's sort of the final operating model I settled on as in a quasi MLE context. The dark blue line and the shaded blue area is the dark blue line is the median, the shaded blue area is the 90th percentiles or the 90th credible interval, you might say, bootstrapped interval from the actual operating model. So when you do that bootstrapping, it changes it slightly from where I ended up conditioning it. And that's for a number of reasons. One, I reject simulated population trajectories that go way outside this range. Every once in a while you get one that might go extinct or you get one that goes way up high. And I'm just saying, if it's outside of fitting all these data sources by, I chose like a value, if the likelihood that I calculate for this is 3 times greater than what the conditioned model was, I just reject it. And that 3 was determined on just defining a decent size confidence interval here that's slightly larger than what the assessment produces.
But the conditioning really doesn't change anything after 1990 or so, even before 1990. Looks like it's only marginally improved.
And marginally improved by, you mean, as compared to the stock
Compared
assessment?
to the OM median is the preconditioned.
No, the OM, so yeah, so sorry to confuse you. The OM conditioned is sort of the process I go and I find like the single best set of parameters. The OM median is after I do bootstrapping to bootstrap all those parameters and the uncertainty in those parameters. And so theoretically you'd think, why is not the median on the dashed line when it should be? But there's just some trajectories I have to delete because they just go way out. Yeah, but
That makes more sense.
yeah, yeah.
Conditioning doesn't matter at all.
But you make a good point, is comparing this to the previous model, previous conditioned operating model would be pretty interesting.
It would be,
Yeah.
To see how much you had to see how much that reconditioning changed things.
Yeah, and for this this single model, the assumptions were not changed, except the assessment had been updated, and there's some slightly different estimates. So I imagine it's very similar, but I will do that comparison.
And how will you do that with the new M values? Will you use the estimated M values input into the operating model?
So that's the idea, and that's where, the challenges come in that. That's really a whole new sort of paradigm that has taken me quite a while to get a good fitting model to that new M value in the short concept. But the two longs were easy. I mean, I came in, I updated everything, added another year catch, and I only had to do a few investigations to get to this point. So I imagine this model, and then this one's based on I think these have the same axes, so you see how different they are. This one's based on the coast-wide assessment, and I think they're very similar to what the previous operating models look like, because it was not hard to get to this point. Once I started bringing in the short models, it became more challenging because it's a shorter time series. You have to, I can talk about that as well, in that I originally thought, maybe I'll start in 1958 for these longer operating models. Why did I start in 1992? Then I realized there's not really any PDO regimes to estimate these differences. So I thought, I'll just have one PDO regime. And only one, not have movement and recruitment distribution change over PDO regimes, but then simulating in the future didn't make much sense. So went around the circle on that, but I have now moved to setups that start in 1958. All operating models or all these individual models will start in 1958, meaning I have to take some parameters from the long assessments, even though I'm going to condition to the outputs of the short assessment. So I have a plot I've created this morning on my computer that looks like it's pretty good for one of the short models. And the main difference there is the red part starts in 1993 and all the blue starts, the whole time series. And it's just sort of trying to mimic that 1993 and beyond. Biomass and other data.
So why do you get that notch here? Step there.
Yeah, no, that notch and that step is that.
That's the 87-year class hitting a really steep part of the maturity. We've got a huge year class, and it really kicks in fast. The maturity ogive is a truncated logistic with truncation at the low end, because as logistic fits often do, there is a protracted sort of takes several ages for the last few fish to mature. But on the low side, they're not mature, and then they really kick in fast at a certain age, unlike like many species.
6 or 7.
6. I was gonna say.
Yeah, it's actually 8, but that's what's going on.
Yeah. So that's the conditioning process. In September, I can give you a full report what trajectories look like and more examination on that in comparison to the previous OMs. Last time I conditioned the models, we talked about, we found that I needed to have all 4 models. With only these 2 long ones I'm showing here, the SPRs were really out of sync with what the assessment was suggesting SPRs. And so having all 4 models really brings it in sync with the advice that was coming from the assessment. So there wasn't that inconsistency there. Okay, so with that, are we ready to move on to the last topic, exceptional circumstances? This is probably the most fun.
The most fun one?
Yes.
Should we get some coffee for that? Okay, so it'll take 10 minutes.
Thanks for revisiting some of that stuff, Alan.
Oh,
I
no.
know a lot that you've talked about before, but it's a long time in between meetings.
Well, a week ago, I revisited it all for myself, so.
It's just the mic and the.
Oh, yeah. Okay, I think we're gonna restart for those online. I'll just get the camera going here. Owl is back up. Okay, this is the final topic of the MSE presentation. And I want to just give a little bit of background here. It's talking about exceptional circumstances. At the annual meeting in last January, the commission on actually the last day, we began a discussion about these exceptional circumstances. And where it came from was what we were just talking about with the stock assessment and the indices. The survey, coastwide survey, WPUE has been declining, but there's been an update to the stock assessment with this natural mortality estimated in a third model that now changed the results and says, oh, you can increase the TCY. A higher TCY is more sustainable now. But the indices are declining. And so there was concern, and this was contradictory for a lot of people. And some people thought of it as an exceptional circumstance. And so the commission, after attempts to explain what exceptional circumstances in MSE context are, the commission was concerned, like, well, what if there's a multi-year assessment and this was a year without an assessment? We saw some big drop in the survey, you know, would that be an exceptional circumstance? And what do we need to do about this? So they came up with this recommendation for the Secretariat to develop options in responding to exceptional circumstances that would trigger a stock assessment in those non-assessment years. And that, you know, comes from really a recommendation the SRB made at the last one. And I think this is actually a really good definition of exceptional circumstances from the SRB. You know, depart from their expected distributions, would reopen the operating models and testing procedures to justify a particular management procedure. So what we did at MSAB meeting in May was provide some education on what exceptional circumstances are, because I think there was some confusion that this was an exceptional circumstance where the assessment was disagreeing from the indices, or the advice was different from the previous year, and it was disagreeing from the indices. And I tried to explain that's not really an exceptional circumstance. That is more of what MSAB came up with a name, they called it unusual circumstance, or something like that, you know, like unexpected circumstance, I think, something like that. And so it was unexpected. It was a cause for a lot of discussion, a cause for some concern, but it wasn't exceptional circumstances we're defining here in the MSE context. So I really wanted to separate that out. So I have some definitions here, you know, from DeMore et al. Is that 2022? I don't know if that, I think that year's right.
There's a
Anyway.
recent paper that they did.
Oh, yeah, it is 2022. Right. Yeah, it is 2022. Yep. But anyways, a couple of things, couple of points that the SRB has brought up should be based on observations, not modeled output. You need to have those clear definitions. Sean, you've already said that in this meeting. We need clear definitions of when the MP should be reopened or reevaluated. And really the key point in this last one is that an undesirable situation could trigger a stock assessment in a non-assessment year. So if there was a drop in a large drop, 15% drop in the WPUE from the survey, maybe that does warrant, okay, let's have a look at the stock assessment, make sure our status and stuff is good, but it's not necessarily an exceptional circumstance. So I really wanted to divide, to separate this undesirable situation from an exceptional circumstance. So some ideas on exceptional circumstances we've been brainstorming here is using, say, the all sizes FIS WPUE or NPUE, and that it just, the actual observed value falls outside of some confidence interval of the predicted simulated value from the operating models. That's an easy one. So that's who it. Yeah, so the second one, it might be another reasonable choice in that it is based on the stock distribution, the percentage predicted in each region. That's actually a big part of the conditioning process, is to be able to predict the proportion observed. The operating model really has to do a decent job predicting the proportion observed in each region. So an exceptional circumstance could be if that departs, since that was really a part of the conditioning process, that could be raised in exceptional circumstance.
So B would be triggered more frequently. Essentially 4 chances to,
Potentially, yeah.
if you want.
Oh, right. Right. Yeah, I mean, that's a really interesting way to think about it. But the other way of thinking about it, well, one reason that we do condition to those data and we want to make sure we're fitting the stock distribution is that the distribution procedure is based on those outputs. We want to make sure the operating model is predicting those reasonably well. But yeah, exactly how you do that, really, I haven't brainstormed on that. And what the chance of exceptional circumstance occurring would be. Yeah, it's almost like a Bonferroni correction. Yeah. The third one is looking at proportions at age, but to be honest, we just threw that out there. It's like, yeah, we could do this. I have no idea how to define an exceptional circumstance on a bunch of proportions at age. Again, if you did it individually, that would be a lot of Bonferroni correction there, a lot of chance of that. So, and then a couple of notes, the operating model is making assumptions about size. So an 032 index has a lot of assumptions in it. So using an all sizes index would be preferable. For that reason, it just reduces another layer of assumptions. So those were some ideas of exceptional circumstances. And then what we were thinking about.
So I'm going to go through all this and then go back and throw out ideas, or do you want them now?
Yeah, sure. Whatever you prefer. They're sort of separate. I mean, it's why we're here. You know, there's concern, and the SRB has suggested defining exceptional circumstances. We want to just make sure that we are clear on what an exceptional circumstance is versus an undesirable situation. The second here is potential exceptional circumstances. And then the third one will be responses. So yeah, if you want to provide any ideas here or in the report.
Well, this is like the first one. The thing about the FIS, it's just so smooth and tight. You would almost see something coming. Yet, like I can imagine, there's a trend that you're looking, okay, if that trend continues, we're going outside. Like it's almost like you could anticipate you're going to be outside the 97th or 95th or whatever. That's a bit extreme. 97. Mm-hmm. That would be a little tighter than that.
Okay.
Because the way like you had it is like, okay, we've triggered exceptional circumstances, then we have to do an assessment. So that you're talking like a year or two down the road, that if something is going on, the response is going to be flagged.
Right.
A bit.
Okay.
And I think what's
necessarily, I think we discussed what would happen if we got survey results in the fall. We could invoke full assessment right away. That fall,
What if
in
we didn't
response to a survey, it's not necessarily a 1-year lag. That was actually something several groups were quite concerned about.
But if you're in a non-assessment year,
we're still going to have to conduct and process the survey information. So an updated assessment using the new survey information, the survey point jumps way up or way down. It's conceivable that we could do an assessment.
It would be an update assessment.
Yeah.
I think about what do a new assessment. The assessment presumably splits the difference somehow. It says that part of that jump is observation error.
part of it's real.
Depending on the interaction between fishery catch rates, survey catch rates, age data.
So what does that give you?
Potentially better understanding of why we're seeing this change, or, you know, is it observation error? Yeah,
1 point.
I know.
Like that's what I'm like if you were in a situation where you had an index that was pretty variable, then one point can really actually be outside that. But here, I think you look at, for example, your simulated FIS, they're going to be doing this, right? So it's almost like if it's doing this, you know, and it's headed towards the bound of the distribution, that would concern me.
Well,
Even though it's not technically outside the 97th, it's,
right.
you know, like when it's doing that, it's going to keep going and it's going outside what your operating model suggested.
Yeah. So, an example from recent history would be, and this isn't on the coastwide. Yeah, I completely agree with you. That coastwide is smooth. You see what's coming. It's not jumping a lot, although it does change by 8% or more, but it's moving with the operating model a lot of the time. What we have seen though is, was it 3A that the survey declined by 18% or 20?
37%.
37% in 1 year. And if that, you know, so maybe looking at it at a regulatory area level where the operating model is just not, or regional level would probably be better. The operating model is not predicting those types of jumps, or it's like way outside what the operating model predicts in the year. There, I think there's more variability on observed indices, and then combining them into a coastwide makes it really good. Then we get into the possibility of 4 things triggering an exceptional circumstance.
I guess my thinking before I asked about what that would get you doing a new assessment is that if you just do a new run of the same assessment, that's not really a robust response.
Right.
Because if it's truly exceptional, and I don't think that this, 5% probability is truly exceptional, we won't be triggering that for 20 years, right?
Yeah.
So if it's truly exceptional, it suggests that the models you have are not capturing some of the real dynamics, and
Right.
just running that same model again is not gonna solve the issue. You need to come up with models with some different structural assumptions.
Yeah. So I think we're getting now into what would trigger an assessment might not necessarily be an exceptional circumstance. So I think this is where, our job is to really provide clarity on what an exceptional circumstance is. And that would not only potentially trigger an assessment, but it would trigger a look at the operating model and a look at the management procedure. So I think an exceptional circumstance is something that happens and triggers full action, right? Of some sort of action. But there's this other concept underlying all this. And it's like, the survey changed by 10%. I wasn't expecting that. I want another assessment. Right.
Yeah,
And that's different. From
and that's not really exceptional, right?
Yeah,
I
exactly.
think I would define exceptional up, but also define the response up.
Yeah.
So that exceptional is some kind of persistent, not single year, but some kind of persistent deviation from the simulation, simulated index that triggers something more than just rerunning existing models sooner than you would otherwise, but triggers some more, as we're saying now, wholesale reevaluation of the assessment and operating models.
Yeah.
And the management procedure.
Yeah. But then underlying this whole conversation, and this is where I think many people were getting confused in that they were saying, well, this is an exceptional circumstance that the survey keeps declining. It's like, no, it's not. The operating model has been predicting that. That's exactly what the operating model is showing.
That's why you do that.
But their concern is, if this was not an assessment year, I would want an assessment this year. So we're also underlying this is like, okay, what are triggers that would trigger an assessment? And my response to that was, well, we can put that into a management procedure. A management procedure does this, does an assessment every third year.
So
If if the coastwide index changed by more than 15%, an update assessment would be done in the month that would allow that period to be done. So I'm trying to put that into context that that's part of the management procedure versus the exceptional circumstances, just a reevaluation of it.
I think you really want to separate this, and it's valuable to define both of them.
Mm-hmm.
Exceptional circumstances should be rarely triggered and should trigger a big response. A real reevaluation, not just trying to be frank assessment.
That's what I was saying. Like if you're seeing a pattern develop over time that is not consistent versus a one-off.
Oh,
so
right.
It's up or down.
And Olaf, you mentioned about persistent sort of, yeah. So that relates to that, I imagine.
So I guess you've got some condition that triggers it, and then the response is then dependent on whether it's
Right.
signaling something really bad or something that's if it's positive or negative kind of potential consequence, then you respond.
Yeah.
Yeah, and you can think of like, what are people going to? The idea of exceptional circumstances that you don't get this, where you don't get people coming in and saying, I don't like catch rate my area.
Yeah.
I
So
think
we
it's
need to
exceptional
reevaluate it. Yeah.
There's something defined. So but you do have to anticipate that if things are really going bad, the fist is the obvious. That's really the anchor. Of
Yeah.
Everything.
So, yeah, I mean, that was one thing is we're planning to use the FIS as the observation to define what an exceptional circumstance is. Exactly how to do that, we're still brainstorming. And I do take your point, the coastwide FIS is pretty smoothed out once you combine all these areas, but potentially looking within regulatory areas or regions might be a better look.
And it may interact with, I mean, one of the multi-year options was to use a constant distribution of TCY in the intervening years. So if you're in a constant distribution and you see a huge change in one area, that interaction, that's actually probably not a good situation. Where if you have a distribution procedure that's responding to changes in the survey, then that's built in. You don't need to, you've already got a response built into the process for that. You don't it's not concerning because the process responds. You don't have to wait. The concern people had was, well, do we have to wait 3 years to catch up to this change? Right. But it's going to depend on the procedure that's in place as well.
It's a dark matter for security.
Any other thoughts on potential exceptional circumstances? I mean, we'll continue working on this, but it would be useful to start by September. We'll hope to have some potential exceptional circumstances defined for consideration.
And I guess it's at the time you adopt the procedure, then you would run projections and establish for let's say for the next 10 years
Mm-hmm. The bounds.
in every exactly what would be required.
And then test that once you get the FIS results. Test those bounds.
So you could leave it as something. This isn't pretty infrequent enough. I mean, if it happens once every 20 years, it's not the end of the world. But you would report on it every year. And you'd say, how are we with respect to our exceptional circumstances definition? We're headed towards it.
Yeah, right.
Or we're not.
Yeah,
You know, that kind of thing.
if it's defined as some persistent deviation, then the first year that criteria is sort of a warning. Next year it might be triggered, and that gives you a little bit of time to response as well.
Yeah.
So it's not just, oh my God, your year is really different than you thought it was. This index came outside the bounds. Well, it was outside the bounds last year. If that happens again next year, we'll be spending all our time on this.
So you might want to put like, in years, and this to be determined.
Yeah, okay. Okay, next one. Anything else? Or should I move on to responses? So in terms of responses, and we've been communicating with stakeholders, commissioners on, this is really specifying an MSC program of work. Exceptional circumstances triggered, specify a program of work, which could involve reconditioning models, re-examining management procedures, but what is that going to entail? But it is a reopening of this process, the MSC process. And also, if it is a non-assessment year, it may trigger a stock assessment. And then again, the timing issue is something that's been a lot of concern. It's like if we find out in mid-October that the FIST is outside and we need to do this, then yeah, that's a lot of ramping up for me and Ian to get a lot of
Yeah,
stuff
you don't want
together.
that either. Yeah, that's like you said. I mean, it should be something that is, unless it's catastrophic, which it would have to be way outside
Right.
of that. But you should see something coming.
Yeah, and I think with the, defining maybe in years, okay, Ian, we've got to have all the data together next year because there could be.
Yeah, and if you see it trending and you're not outside, but you're headed for it, then it's like, okay, we're going to be ready.
Yeah.
In case it does go that way, it's not so disruptive.
Yeah, okay, so we're really, in the process of educating the commission about what exceptional circumstances are, and then also about what these triggers in a stock assessment might be as well. So we'll see where we get to from here. This is really helpful.
And then what is the stock assessment going to tell you?
Right.
We would have to tell you something
It-
really different, which you kind of anticipate.
That was my point. So
Yeah.
right, this thought, I know what that's.
And how would you use that? Yeah, right, you got to make sure that's defined as well. Okay, so the final little bit is just a review of everything we've talked about in terms of what potential recommendations might look like. Just noting those additional simulations, and that was useful, but relative comparisons didn't really change much. Couple points on the PDO regimes had little effect on that priority conservation objective, or that relative spawning biomass, but on yield affected long-term distribution of spawning biomass in each region. And it's it's a way to look at fishing effects and the environmental effects, and how they affect each region individually. All of these are in the document as well, these suggestions. The SRB endorsed that process for conditioning the 2023 operating model and request. And so that leads to, if there are management procedures that the SRB would like to see tested and evaluated over the next 2-year period, now's the time to start making those requests. Although the MSAB has the conclusion of the MSAB in last May was to wait until there's an agreement, a distribution agreement, before we start defining and testing and evaluating management procedures. If they'll started now, and then there's an agreement, we'd have to do all of it.
I think some,
Bringing over this.
Yeah, right. But yeah, the commission is in their process of coming to an agreement on a distribution procedure. Just not sure when that will happen.
one thing you may want to think about in developing the exceptional circumstances is things to do with the survey. So survey funding is cut. You're not doing it this year. Somebody's going to say that's an exceptional circumstance, right?
Right.
So you might want to run some scenarios where you leave out survey altogether, or leave out a survey in one area, something like that, so that the MP is already going to be able to deal with that. So you pass through your,
Right.
same idea with other things like catch, maybe the odorless or the catch wasn't processed, or think about some key data source that's missing.
Mhm. With the space-time model in the survey, missing a year isn't a big problem. We could still get a prediction out of it. But it's a lot of uncertainty around it as well. But you're right.
So you'd have to think about how you're going to actually simulate a missing
Mhm.
this, what would happen. And then-
Right, right.
So yeah, you may end up in the year that you simulate a missing one, filling it in with a higher variance observation.
Okay,
Just leave it out altogether.
right.
Say like,
Mhm. Yeah, that's a good point. And then finally, the exceptional circumstances that we discussed, and any sort of recommendations on that would be useful. Requests. And that's it. That's all the fun that I have for you this morning.
it's fun. Okay. We have lunch coming. 12:30.
Something about that.
Okay, so I think we can move on. Thank you, Ellen.
Thank you.
All right. Well, we're going to get started with the report on the current and future biological and system science research activities. We should be able to wrap this up before lunchtime. What we're going to be reporting on is an update on 4 of the 5 research areas that are contemplated in our 5-year program of integrated research and monitoring. So these 4 areas that we're going to talk about today are migration and population dynamics, following by reproduction, mortality and survival assessment, and then fishing technology. And for each of these research areas, I'll ask the staff members involved in these different projects to speak to them. But I'll give the first sort of brief introduction to the migration and population dynamics area. This is a slide that you've seen before, but it summarizes the different projects that we identified as potentially interesting within the current 5-year program of integrated research and monitoring, and how these ideas or projects have evolved from the previous 5-year research plan. The first one that I want to mention is the mapping of settlement and nursery areas. And in a minute, Rory Doris will speak to that. And this is the first project that we've started working on related to migration and connectivity, because this is directly linked to the study that Rory conducted and was published finally in 2021 regarding larval connectivity. So you will most likely remember the work that she presented a few years ago regarding the use of modeling efforts to determine larval dispersal pathways from a series of known spawning grounds, and the level of indoor basin and intra-basin level connectivity. This her project is really now intended to link this published work with nursery areas and establish a level of connectivity between spawning grounds and settlement and nursery areas. So Lori, go ahead.
I think you had one more slide there, actually.
Yeah, go ahead.
Go ahead, okay. Okay, so this is a work in progress, so there's not a ton to report, but we have been gathering data for the past several months, and this is pretty much data on occurrence of age zeros, age ones, and age twos. Sometimes it's based on the actual age of the that's determined by the otolith. Sometimes it's based on size as proxy. So this just gives you an idea of kind of the span of the data that we have found through 11 different data sources. And it comes to a little over 52,000 records of occurrence. And so the first ones were in 1946, and we have it recorded now up to 2022. And the top row is the age zeros. So obviously those are the ones that we're most interested in. The age ones are also pretty useful, actually. The age twos, you can see there's quite a few of them starting in the mid 90s, which is when the fall surveys really started to pick up, and the twos do show up in the fall surveys. Just gives you an idea. There we go. Okay, so from there we just did some simple mapping. I actually wanted to redo these maps for showing them to you, but unfortunately my mapping software is not working at the moment. IT is on that, but you can get the idea here. So on the left is age zeros, in the middle is age ones, and on the right is age twos. The little green blobs are spawning grounds. And on the maps, you can just see occurrence. So it's just the dots are just occurrence. And the pink X's are where we would have expected to find halibut. It was, they went there looking for flatfish in nursery grounds and did not find halibut. So that is a real limitation of the data, is that for most of the projects, most of these data points, we don't have any information about what the project was, what their goal was. I mean, did they just go there looking for flatfish, or was it some kind of randomized survey? We don't have an idea of effort, that sort of thing. So that's a limitation. Ray Webster is helping me with that. And so you can see that age zeros, there's, they're pretty much, all over the place, except for kind of the Central Gulf. There's a bit of a lack, and we don't know whether that's actually a lack of the fact that people didn't go there to look for them, or whether there just weren't any there. We don't have that yet. Age ones, you can see there's definitely a congregation there over around Kodiak Island and the Alaska Peninsula and the Bering Sea. And then age twos, like I said, they get picked up in the trawl survey. We do tend to see the young ones in the trawl survey to the west, getting a lot less frequent in the east. But that said, that's the NIMS trawl surveys. The DFO surveys have picked up quite a few twos in BC waters too. And so this summer we have our intern here, William Lee, and he is so Alyssa Abukayer, I think that's how you pronounce her name. She works for the Alaska Coastal Observations and Research. She heads out to Kodiak Island to do surveys, and she has said that she does encounter Pacific halibut. And so she is collecting some genetic samples for us this year, along with, and she helped us dig up a bunch of information. Brenda Norcross, who is now retired, but she wrote some reports and things like that of work she did around Kodiak Island in the 90s. Which has a lot of unpublished data in it. And so she helped us dig those up, and William will be helping us to mine that data this summer. And so hopefully that'll kind of loose square there. Hopefully that will fill in those data points a little bit. And she said that during those studies there are a lot of age zeros. So we're hopeful. But again, Brenda went to Kodiak Island looking for juvenile fish. So it wasn't sort of a survey through the atmosphere. So another part of this is to map substrate layers. And so we found the US seabed database, and those are all the points. So this is point data. And but it's pretty good. And so, you know, there's different ways to look at this. Obviously, the point data is hard to reconcile with point data of halibut, but this is just one way of looking at it. We haven't settled on this being the method, but this is just an inverse distance weighting layer. And you can see there's 5 categories. So the US seabed data is in 4 categories, but then the gravel category is quite expansive. So I pulled some out and made fine gravel. So basically they're hard to read there, but it's mud, sand, fine gravel, gravel, and mixed. And so we can hopefully superimpose that on the data points that we have. And then obviously US seabed doesn't have BC data, but we were able to get a hold of that through Dana Haggerty at DFO. And they have actually created a layer. And so now we do have a coast-wide sort of layer. The next step is to add bathymetry and to try and figure out how to get at this effort issue. You know, with the ultimate goal of creating this layer that is of basically nursery habitat for Pacific halibut that can be used for looking at other things. So, you know, other projects. So Alan spent quite a bit of time talking about the PDO. So, you know, looking at covariates and trying to figure out environmental covariates to settlement, that sort of thing. Figuring out connectivity, as Joseph mentioned the connectivity work for the larvae that we did, and this is sort of that next step. So figuring out the connectivity between spawning grounds and settlement grounds, that sort of thing. I think that's it on that subject. Now who's next?
So I'm curious to ask about the broader analysis framework. It's all this information then going into something like a generalized additive model with habitat covariates.
Yeah, so that's where Ray's going to help me out. Yeah, so right. So the idea first is to make a layer, and then from there, hopefully it can be used for a bunch of different projects. So whether it's to, you know, put it into sort of an additive model, looking at, you know, the PDO, correlation with PDO, things like that. That's sort of the second step after we've sort of exhausted all of the information that we can possibly find and try and get the best layer that we can. Was that your question?
Yeah.
Yeah.
Just trying to understand where this is going.
Yeah.
The analysis. So now
Yeah.
you're at the data gathering phase
Mhm.
for this in terms of the covariates, but also the
Yeah.
response.
Yeah, so we've played around with some things ourselves, but you know, nothing for prime time yet. You know, it's you know, we're kind of looking at the data, and you know, there are definitely patterns and things like that we're hoping once we're able to you know, to really make this sort of this robust layer, I guess you would say, that that we can start looking at you know, the patterns of settlement and things like that, and how that correlates with you know, the PDO or the currents in that year, that sort of thing. And that's all sort of modeling that I'm not a modeler. So yeah, that'll be, yeah.
Right. And so then I'm trying to understand how this will feed into the stock assessment. So I guess you could have different habitats in the 2 phases of the PDO.
Yeah, I'll hunt to
This
Ian
is
there.
this is also setting us up just to better understand some of the potential source sink dynamics. One of the basic questions we want to know is which of these areas even has enough juvenile habitat to produce enough fish to cover the yield that occurs in that area. So which areas are net negative or net positive in terms of the production. And so we know what the range of density estimates looks like when halibut have a range of densities that they can be present as young juveniles in these relatively limited areas. And we can do some of those back of the envelope calculations to try and understand which areas could potentially be self-supporting versus not. You know, how much of the, what proportion of the overall productivity of the stock comes from different regions, that sort of question.
Presumably the transport happens at age 0.
Yeah, so
And that's passive. Well, you could have the best juvenile habitat in the world if you don't have a spawning ground nearby that they're moving from, then, you know, so what? So you have the same good habitat here, but there's no spawning ground that's populating that juvenile habitat, right? I mean, these ocean transport models for pelagically dispersed or high, you know, passively dispersed, very small individuals, it's by currents and a lot of things. So, you know, mapping where the spawning grounds or the presumed spawning grounds are, where the currents are, where the directionality is. I mean, you should have some hypotheses moving forward about where you could expect it. So I said, you got to have the juvenile habitat to support it, but you got to have the spawning grounds for them to be able to populate the juvenile habitat. So it's not just as simple as this good habitat because we find them there. You great habitat, you're not finding them there because they just can't get there.
right, getting at that connectivity component is certainly key for sure. And one of the things that I don't know if Andy will be touching on it today, but that is something genetically that we'll be hoping to look at too, to be able to genetically link, you know, the connectivity of spawning grounds to different settlement grounds, things like that. That's all in the future, of course.
A great close capture recap.
Yeah.
It seems like you could use the results from this habitat model for different ages to parameterize the movement coefficients. Yeah, you've got a distribution of age 0s 1 year, and distribution of age 1s the next year. What do the coefficients have to be in order to match those observed differences?
Yeah, we've talked
One
about
way
that.
of really integrating this into the stock assessment. I mean, certainly there's value in generally understanding the processes, but if you can link it directly through estimation of those movement parameters, that seems like
Potentially. And there are a few places where we have discrete enough areas where there's maybe some specific information. In a lot of cases, there's potentially a wide range of sources for those ones
there
in the
are
previous year. So,
sure, but I think you can essentially try all the values and
Yeah.
see if there are some unique combinations that get you there,
Yeah.
or if there are combinations that you can eliminate based on the tagging data. Like the tagging data is
yeah, the tagging data is really ages 2 and up. So this is the only way. These are the only tools we have for these post-settlement pre-sampled really fish. These take dedicated surveys. These fish are all smaller than our state routinely caught in trawl surveys.
yeah. So well, I mean, at least you can get the sort of set of movement parameters that are consistent with the observed distributions.
The other thing we're
The selectivity differences between age 0, age 1, age 2. Because some of what you're seeing, I'd imagine in those maps, is them just growing into the gear, showing up.
the twos are, you can catch twos in a trawl survey. You can't catch zeros, really. Although there are a few that get stuck in a small mesh.
Right, but I think if you assume that the selectivity is constant across space, you can still parameterize the movement along. Like, yes, there's no reason, biological reason to have more H2s than H0s, right? Something like that. So that's all selectivity. But if selectivity is constant spatially, and relative distribution of H2s compared to H1s tells you about movement. Either about movement or about differential mortality. That's
Or it's, you got to have effort. You have different effort, but you're saying.
I think that will be dealt with once they map that.
So you have some idea of effort that went into these different,
No, we don't have any idea of effort.
you could go out there and you could spend twice as amount of time 1 year than another year.
Right.
getting some number of age zeros, some number of age ones, and how to make sense of it.
Yeah,
If
again, it's
you-
about the spatial distribution, not the absolute abundances. So the difference in spatial distribution between age zeros this year and age ones next year.
Okay, that-
Not the absolute abundances, right? Because the absolute abundances do reflect effort and selectivity, but the spatial distribution really does not.
The other important angle on this of just mapping the potential habitat areas that we don't know. I mean, what we see now for occupancy at these young ages reflects where the current stock is. That doesn't necessarily reflect where the stock has been historically, nor under certain scenarios of climate change, which of these habitats might receive recruits from various current or future spawning grounds. So just having a roadmap to where these small fish, the habitat that is available to these small fish is huge, would potentially be a huge step forward for us, particularly in the northern areas where we might not see fish right now, but it's potential habitat if spawning occurs at times in places that would get those zeros there under current or future circulation patterns, circulation temperature, and survival combinations.
And one thing that William's looking at this summer too, is co-occurrence. So where we don't have halibut information, for example, they may have, some northern rock sole seems promising, for example. Northern rock sole is often found with juvenile Pacific halibut. Sort of looking at that as well to help determine nursery areas that could be nursery areas, but where they just maybe do a purpose in halibut.
So what age are they more active? The earlier published work suggests that there's some sort of transport into the Bering Sea, and then there's active movement out. So
Yes.
do you have an idea when that, based on your earlier work, when that occurs?
So we base that work on the trawl surveys forward, so the 2-year-olds and up. And so we've done a little bit of looking at densities of the smaller fish, and it does look like maybe they move around a little bit, but we haven't come to any conclusions on that yet, or a way to look at it sort of standardized across areas. So, yeah, but it does look like they're probably, age zeros probably are just settling down, finding a spot, but by age 1, they do, we have age 1s. Go back 2 slides, please. We have age 1s in like out on the flats. There we go. So age 1s, the sources that we had first were all along the Alaska Peninsula and in Bristol Bay and up kind of near shore. But once we got the observer data, the observer data was showing that there were some fish out on the flats already at age 1. So, and actually even age zeros. We don't know whether, we did ask some people over there in the observer program, whether they thought maybe they had been misidentified as, but the people that we talked to said they didn't think so, that identifying juvenile flatfishes or juvenile Pacific halibut is pretty easy compared to other flatfish. So, this suggests that they are moving out onto the flats if they've been pushed up into Bristol Bay, or they're moving off the edge and moving into Bristol Bay. It's hard to tell.
Okay, if there are no more questions, another project that we're working on, and Andy Jasonovich is gonna provide an update on, is on the population structure. So delineation of fine scale structure is one of the objectives of this research area. Okay, go ahead, Andy.
Thanks, Giuseppe. So yeah, I have a few slides as an update on the progress we're making on the population genomics research that's currently underway, of which the main objective is really to resolve the genetic structure of Pacific halibut stock in IPHC convection waters. And so just to reorient the SRB to the samples that we have collected for this project, the locations of the individuals that we're including in this analysis are shown in the map here. And they were collected between 1999 and 2020 from 5 different geographic areas. And the important thing to note about these samples is that they were collected during the winter time, with the assumption that the fish are on the spawning grounds at the time of sampling. So we're utilizing low coverage whole genome resequencing for this analysis, and this is a very high resolution method that enables us to sample, essentially sample every single base pair in an individual's genome. And yeah, I'd just make a quick mention of the Pacific halibut genome. So this resource was published last year in March of 2022. And without this, we wouldn't be able to take on this sort of study, specifically utilizing whole genome resequencing. So the sequencing and data generation portion of this project is completed. We don't have any plans to do any additional sequencing at this time. And so on this slide is just a brief summary of the 3 sequencing runs that we've done to date. That was actually contracted out to the Norvegine Corporation and done at their facility in Sacramento. And in total, we've generated just shy of 16.5 billion sequence reads. So quite a very large data set to work with. We submitted a total of 610 samples for sequencing, and based on initial bioinformatic processing and quality control checks, 604 of those samples have usable data. And when I say, I guess, yeah, and essentially the main criteria we used was genomic coverage. So if we had enough sequencing data that we could achieve 1.5x coverage, those samples were retained for downstream analyses. So on this slide, this figure is a visual representation of the workflow that we're using to process and analyze this data. So in each box is a brief description of this step and then the software that we're using for that. And this is just to give an idea of, a visual representation of how data is, we plan to, the data flow through this for this analysis. So this figure was modified slightly since the last SRB meeting in response to some recommendations, specifically additional analyses related to unsupervised clustering and the estimation of relatedness coefficients and pairwise genetic distance among individuals in our data set. And so those steps are highlighted in red here. And then additionally, additional analyses to estimate Tajima's D, which is a statistic that can give you an idea of if you have an excess of rare variants or common variants present in your data set. So we've added that at this stage, at this stage of the workflow here. So like I said, the data for this project has been generated. And so that's enabled us to move on to some of the analysis portions of this project, which we're currently, that's currently underway at this point in time. But we have been able to proceed to SNP detection and estimation of genotype likelihoods. And that's shown in red here. And then in the box in yellow, that's a description of the various parameters we're using to detect SNPs and estimate genotype likelihoods. And I won't go into really any details, but if there are questions, we can address those. But using this set of parameters, we have identified approximately 10.2 million SNPs in fully assembled autosomal regions of the genome. And then applying a minor allele frequency threshold of 5%, we have about 4.7 million SNPs. And this is a filtering threshold that's used for, commonly applied for some of the analyses that we have planned, like principal components analysis. So while this indicates that we have a lot of low frequency SNPs present in our data set, there still are plenty available for the analyses that we plan to do. So here, I've highlighted all the boxes in green are the steps that we've completed, and then the steps highlight or the boxes highlighted in yellow are what we're currently working on, or what we were working on at the time that these documents were published. So to give the SRB an idea of some of the results that we're generating from the analysis of this data set, I thought I would show a few figures here to demonstrate that. So these are Manhattan plots, and they're a way to visualize statistics across the genome and their, the position that they have of these estimates for these various parameters in the genome. So this is a Manhattan plot of pairwise FST between two sample collections, British Columbia and the Bering Sea from 2007. And so to estimate this, it requires you to predefine population groupings. In this case, we're just using sample collections. And values of 0 indicate complete pattern. So FST is a measure of genetic differentiation or genetic distance. And so a 0 indicates that would imply complete panmixia or no separation between these groupings. And 1 would imply complete separation between the populations that we're defining for this analysis. And so I'll say these values are generally low across the genome. There are, some some regions of the genome showing elevated estimates of FST that may be interesting to pursue for downstream or interrogate further.
Andy, can you convert those results into something like number of individuals per generation?
Yes, I mean, in theory you can, but since these are, I guess since these are genome-wide estimates, so these are specific to a certain gene or SNP genome. In order to do that, you would need to, I guess, collapse those, values into a single estimate for the, across the entire genome, right?
There are several processes that lead to degree of differentiation. One is movement, right, or lack thereof, the less movement between areas, and generally exchange the height of the value, right?
I understand the directions.
Right,
It's like
right,
trying to translate these.
But the other is just finite population size. You can get genetic drift, right, which could lead to, so it's more than just movements that are higher or lower. It's a function of the effective size and the magnitude of just stochastic change as well as, so there are multiple things that are contributing to, and potentially selection. You could have some selection going on in some of the regions that are locally very highly localized on specific areas of chromosomes, right? I mean, these are very tightly packed samples, which suggest there could be some sort of selection happening. So all these things could be contributing to higher levels of FST than others. I mean, there's a background level, and one of the things that Andy could do would be to establish some level of statistical significance, right? So these are raw values.
Right. Yeah. These are just,
So there are ways that you could like a C transform or a log transform based on that, and just to get some ideas. Well, how surprised am I that I have a value relative to the distribution locally? So
I guess what I'm getting at, is there some way of getting from these results to questions of relevance to stock assessment management?
I mean, certainly, to look at migration rates, right? And if you could say, take these markers that are in these regions of the genome, use that to assign individuals back to a source population. I mean, you could get essentially contemporary estimates of movement between populations or spawning groups, right? But we're not there quite yet with this data set.
Is that where you're heading?
I think, yeah, I mean, in an ideal scenario, yeah, that's where we're going. But yeah, like essentially, yeah, we have to see like, I guess, how accurate those assignments would be before you like, can we, do we actually have the ability to do that, or, using samples of known origin essentially. So like, like cross-validation kind of procedures. So, but yeah, that would be the goal.
I guess I'm just reading the title, Migration and Population
Sure.
Dynamics. I'm trying to see what we get from FST to
Sure.
to there, and
Sure.
I understand that there are many factors that can go into that, but can we still say something from this about migration and population dynamics, or no? Are there too many unknowns?
Well, yeah, I mean, I guess, yeah, not at this point. I mean, this is very preliminary still. So, yeah, I guess we're trying not to say too much about it right at this point in time. But that's it, But I guess, so in these figures down, this next set of figures, so Tajima Z, that's another statistic that we're estimating from this data set. And this is estimated from single populations. So again, and these are the two populations that we're comparing in the Manhattan plot above. But this can give you an indication if you have an excess of relatively common SNPs in your data set, or an excess of rare SNPs in your data set. And these values can be interpreted to give you an idea of what sort of selection might be acting on these populations, and also demographic processes as well, like population expansion, contraction.
Why they look identical?
Yeah.
They're from two separate populations. Why would they be so similar?
Well, I mean, I guess, so these are just, populations that we're defining based on this sample collections, right? So I guess, one I mean, in reality, they're probably very genetically similar, right? Like they're collected in two different areas, but they're from the same population.
Well, there's also,
I'm not sure what I'm looking at. Well, I don't know. I don't know anything about this, but I mean, it looks like the same plot.
Yeah.
Literally, the
Right.
points are the same.
Well, I guess, I mean, really, essentially, the allele frequencies would be very similar.
That's what those are.
Well,
well,
not
there's
necessarily,
two
but-
sources of
yeah.
variation, right? There are two components. There's a parameter called theta, and there are two thetas that you can estimate from the allele frequency data. One is it estimates the number of pairwise differences, and the other one is a theta related to portion of rare alleles. And if the latter is higher, that theta, than the former, then the value is negative. And theory would predict that you get negative values under circumstances of selection, or under circumstances of population growth. So the values are generally negative. It's interesting that the values are more negative in the center of chromosomes. So you see the light blue, dark blue, light blue, dark blue going from left to right. You're going from telomere to centromere to telomere. So you have this V pattern. So there's heterogeneity within a chromosome in areas. The centromeric areas are areas of heterochromatin. They don't code for anything, right? They should be selectively neutral, and there's less variation. So the value is negative, it's more negative. So that kind of, the heterogeneity within a chromosome kind of makes difference. The fact that they're all negative, the fact that we bought this yesterday.
Yeah.
They're like carbon copies of one another. There are some artifacts, I think, that deal with the way that the data was filtered.
Yeah.
And so I would give the Tajima value much, until you understand a little
Right.
bit more about what's going on there
Right.
now. I don't really,
But in any case, that's just to serve as an example of types of data that were results that we're generating from from the analysis that we're working on right now. And we did prepare an additional slide. I don't know if can the communications team bring that up for us?
So can you extend that to the age distributions as well?
Yeah. Do I?
No, just go
Up there,
upper.
the little box with the brackets around it.
Oh,
This
right
way.
here.
Yeah, but those are the values of individual SNPs in windows of 15,000 base pairs.
15,000 base pairs. Yeah.
You know, so it's a moving sliding window of a summary. A point is a summary of the median value of a window, and the window is 15,000 base pairs. You're going from one end of the chromosome to another across each of the chromosomes.
So, yeah, we put this slide together yesterday. Because Kim made a comment about the results we discussed with him yesterday based on the initial principal components analysis we did. And so this figure here, or this analysis was done using approximately 4.7 million SNPs, all in autosomal regions of the genome with a minor allele frequency greater than 5%. And so I guess let's walk through this figure here. So, okay, well,
Very good. Next.
12:01 p.m.
You really want to see the age distribution.
yeah, you want to see the age distributions, but
Move one forward, maybe.
no, this was only one slide.
That was my stomach.
Adobe cut something out.
Yeah, Adobe cut something out of
Adobe
this.
does
Well,
that.
Well, that's too bad.
Yeah,
because that's really important.
yeah, that was
You
really,
really
yeah,
need to see the
really
age
key.
distributions there, the different cohorts represented in each one of the
Yeah.
years and each one of the populations. You can't interpret this.
right. Without that,
What this is an ordination, right? And the dots there in multidimensional space reflect the degree of similarity or difference, across all these steps, right? So things that are clustered closer together are genetically more similar. One of the assumptions in mixed stock analysis is that you have genetic homogeneity over time. You can look at the differences, right, from was the top, the earliest years.
I think it's probably coming back with the whole
Yeah,
thing.
let's hope.
I think he's trying to fix it.
come on, Ed. Hope so. There we go.
Yeah. It's got all kinds of tricks. Figured he was working on. That looks good, Ed. Thank you.
Great.
So I can,
Yeah.
what really caught my eye yesterday is, so these are individuals that were captured and genotyped here, and you can see they're here, which are really quite different than these individuals right here in this year. So this is 1999, this is 2004, and this year is pretty similar to just the distribution of points in multidimensional space. So these gray areas are all points, right? You're just highlighting the blue and in these different years. And so similar, but really different. Look at the age classes. Similar distribution of age cohorts, year cohorts, very, very different. Look at these guys. These are really quite different than this distribution, but this is a little bit more similar and these are different. Look at the distribution of age classes. You got these guys here. This is the number of individuals in each of different year cohorts. Very, very different age distribution, very different age distribution, et cetera. Here you have something that's very similar in 2 different years. Here's 2004, 2007. Very similar age distribution, very similar age distribution. My way of understanding this is you've got heterogeneity in the genetic association between these points, and it's due to the fact that you got different year classes. So that's not movements, that's the relative numbers of individuals that are producing, or the individuals that are producing those individuals. That is striking.
You would orient regarding the dash line?
Oh, yeah, well, so that dash line, yeah, that's just placed at 1987. You know, for reference, because that's the strongest year class of halibut ever, right? So,
And the same thing for Central Alaska, the light blue, right?
yeah,
So you see very, very differences in the distribution of the points there. And then you take a look over at the age structure, the compositional, you've got completely different year classes in those 2 time periods. So the difference, so you have temporal heterogeneity in the genetic associations among individuals, right? These are just genetically different groups of individuals. And if you had one large panmictic population in each area, you should have homogeneity within an area across time. You don't. So there are different groups of individuals that are reproducing in these different years, and it's reflected in different year classes represented in the samples that were genotyped, and they're really very different each year. And that's cool, but
Yeah.
it's kind of complex.
right. And I mean, I guess, yeah, I mean, there's not a lot of spatial structure, it seems, on east and west of Chickamass, right? Which was kind of the reason for going and sampling those 2 locations in 2020. Because previous work suggested that that might be a key oceanographic break, separating, delineating 2 different genetically distinct populations. But this, suggests otherwise.
One caveat here is take a look at the proportion variance explained in each of the
Yeah.
principal components. I mean, and so my suggestion to these guys is go back with an outlier analysis and cherry pick your loci where you have really good discriminatory potential, right? You can do this in a pairwise, right?
Right.
So it's not just the mean FST across all interregional comparisons, but choose a better set of markers. I mean, this is discovery, right? I mean, you're in a still discovery situation. What you want to do next is, depending on what you want to do with them, like identify populations, choose the markers where you have the highest discriminatory potential, and then use those in the analysis, right? I mean, choose your objective, and then subset the loci that you want to use to best achieve those objectives. And the best way to achieve an objective is to use high FST loci.
Yeah, and those were those peaks.
The ones that are
those
higher.
figures, yeah.
That's right.
on previous
And then
slides.
it would be interesting to understand, based on the annotation of the genes that are associated with these SNPs, why do you see those genes, those SNP regions in those areas of the chromosome, which are more, why aren't these just like the body of the loci, which are lower? Potentially they're under selection. Potentially that would be a hypothesis. You could find, based on the gene annotations of those genes, what the function is. And
So Kim, as a non-geneticist, I'm kind of scratching my head trying to understand how you can have apparent differences between cohorts, but not across space. So where do these cohorts come from that they can be different, but yet all the source populations, at least in some years, seem to be similar? I'm trying to picture a meta population with a bunch of circles and arrows that could create this. I'm having a hard time even hypothesizing what that might look like.
well, I mean, you're looking at, you have variance in the frequencies of alleles represented in different cohorts, early cohorts, right? And later cohorts. And that's, if you have an idea of the number of individuals reproducing, or maybe it's a different subset of individuals that are reproducing, that are producing those older year cohorts and the newer year cohorts, then that you could predict what the variance in allele frequency over time is, right? It's just the frequency of the alleles divided by 2 times the effective population size. So you can estimate what the variance is if you know the number of individuals. It suggests that the number of individuals producing, or it's a different set of individuals producing the cohorts, the earlier cohorts and the later cohorts. And that could be due to a number of factors. But if you're sampling in the same area, you're assuming you're sampling the same pool of adults or same draws from populations in each different years, but you're not. You're sampling individuals that are different ages. And for something's going on which are causing, just based on the ordination of those points in different years in the same population, right? Blues going down from older years to younger years. And in some of these areas, you have apparently you have differences in the age composition of those individuals that were genotyped, and they're very genetically different from one another. So you have more heterogeneity over time. Again, the caveats of, you're dealing with 4 million loci. Most of them aren't telling you anything because their FST is 0. So there are several things. Number one is try to increase the variance explained in your principal components by reducing the number of loci and see what if this pattern continues to hold. But it basically says that the fact that you have transitions of individuals in these different sampling years of very, very different year classes, they've got different parents. They have to be, otherwise they wouldn't be quite that different. And so you're either not sampling the same areas, or there are relatively few adults producing those individuals in those different year classes, and that's leading to the variance. Just stochastically, you're getting drift, genetic drift.
So this is going to have some implications for the post-kin estimation, isn't it? If you have some parents that are more productive than other parents.
No, that's fine. Now you have to sample more individuals because you have that variance in reproductive success, but you can still do it.
Kind of think about like plausible mechanisms. Is it still back to Ian's question? I had the same question. That it seems like there's a contrast between the FST showing that totally mixed and this showing but different groups are producing. Why could the different groups be like early and late spawners, which are?
No, I mean the difference again over on the right side. Up. I mean, you can see there as you're going from early sampling period 1999 to 2004 to 2007 to 2018 to 2020, in those populations, the columns, right, dark blue, orange, red, light blue, in situations where you have relative homogeneity between one year and another, you're dealing with animals of similar age distributions. In years where you have very difference in terms of the ordination, for instance, in dark blue, 1999 and 2004, you take a look and you're dealing largely with animals of different age classes.
Yeah, I understand that. I interpret it right. I just understand the biological mechanisms that can result in that better.
There are different pools of individuals that you were sampling. I mean, those are animals that are 5 years apart, and you're sampling those animals, and that's the age. Each one of those columns in the frequency histograms of ages are individuals, the number of individuals in that group of points that are of those ages. So how do you go out there and sample halibut that are that different in age distributions 5 years apart? I don't know the species well enough to be able to answer that, but that's what's happened, and genetically they're different groups of individuals.
Could this also be suggestive of lack of spawning fidelity? Spawning site fidelity?
I mean, but you had a slide that showed you went to the same place in each of these different years, right? So but maybe there are different individuals that are spawning in there during those different years, right? I mean, they obviously are. They're different ages.
Yeah, the spawning grounds are stable, but the females and males going to those spawning grounds genetically different.
Yeah, I mean,
Those different years.
so you go down, you follow the dark blues from top to bottom on the right, or from the orange from the top to bottom, they're getting younger, right? So whether that means, the older ones are being harvested and the younger ones are ones that are recruiting to reproductive age and in turn spawning. But they're genetically quite different from one another. So it's really, really quite variable over time.
Could it be that in 99, some of those fish that were there in 99 left that area and were not present in that sampling year? So almost like a cohort was born somewhere else, moved through there, and then maybe came back, or like, is that what it could it be something like that, where they? I'm looking at the gap in the second row, British Columbia one. So those fish are gone.
This compared to this.
Yeah, so that top blob seems to have disappeared in the second row.
They went to the Western Aleutians.
Well, yeah.
You would imagine that's what thing that a bunch of fish are born similar. It's a blob of them, and they're just kind of moving with the blob. They're not.
Well, I mean, the contrast this with the Pacific salmon. The Pacific salmon people, they go out there, agencies, they sample the rivers, over a period of time, right? One of the things that they want to establish is how homogeneous. Are you seeing differences, in the gene frequencies in each of the rivers? So you can do a mixed stock analysis, and you can do it once, and then you could use those data for some year collection, not in perpetuity, but for some period of time. If you're seeing really large differences over time, then you're continually having to update the baseline simply because it's a moving target. And if it's a moving target, there are two reasons. One is, again, this drift, right? You have such few adults that are spawning, you just get these stochastic changes generation after generation, right? The fewer the individuals, the more the change, right? Or you're getting migration. If you're getting migration, you're still seeing FSTs, then that's probably not an explanation, right? Because you wouldn't have significant FST values if you did. So this is interesting. You're getting recruitment of different year classes, and the sampling is everything is moving from left to right, as far as the age distributions in the far right column. And there, in some places, it's resulting in differences, but in the Bering Sea, it's not. I mean, at least 2004 to 2007, right, where the red is, you're dealing with genetically similar individuals, and you're dealing with individuals of similar age composition. So where you're seeing compositional heterogeneity from sampling year to sampling year in terms of age class, you're seeing genetic differences in those individuals in those different age classes. And that's what that says. How to explain that? Not a hell of a
Good job.
Right, that's telling yes. Yeah, yes. Unless there's anything else, I guess Ed's probably got it.
So the blob of gray points is just all points.
Yeah.
Yeah. Yeah, I mean, it'd be a pretty messy figure.
So we have about 10 minutes before lunch. Should we move on and just use this 10 minutes as best as we can? Okay, so we'll move on to the next area, that's reproduction. And what we're focusing in, as you heard last September, is really concentrating our efforts in revising maturity schedule. But also we're introducing this year the collection of samples for fecundity estimations for the first time. So Colin Jones, who's a new member in the biological and system science branch, will speak to that. So go ahead, Colin.
All right. Look forward to providing an update to where we sit with maturity estimate updates, as well as our goals for sampling on the FIS year this year on the FIS for 2023, sampling for both maturity and fecundity. So just to provide a little bit of background information that you all have seen before. So this was a study, our first reproductive assessment project study that started in the summer of 2017 in the Portlock region, which was just east of Kodiak Island. And the goal of this study was to basically address histologically what the annual reproductive cycle of female Pacific halibut is, as well as determine the actual histology staging. So what you see on the figure here in the middle is the reproductive cycle from 30 females that were greater than 90 centimeters collected per month from September 2017 to August 2018. And this just shows kind of that annual reproductive cycle. So you see the spawning stages here in the winter from January and February, and then moving through the vitellogenesis stages as you progress from spring through the fall. And then one of the main outcomes of this was determining whether or not our set line survey was a good place for us to collect histology samples. And so this study showed that majority of the fish in the summer months from the end of May to the end of August, beginning of September, have progressed into vitellogenesis. So it allows us to determine whether they are mature or immature females for that spawning capable for that year. And then also here on the right, what we have determined, the IPH Secretariat, is that we are going to be determining mature females as ones that have successfully progressed into vitellogenesis stage. So this is very common among cold water species throughout the United States and different fisheries science centers. They have indicated that they determine maturity as reaching vitellogenesis, basically. So anything prior to vitellogenesis, so the cortical alveoli stage or perionucleolar stages prior to that, are what we determine as immature females. So using this information, the IPHC Secretariat, we kind of conducted 2 small pilot studies. So using that information from 2017, what we did was we also collected 30 females that were at least 90 centimeters in fork length from the Portlock Charter region from 2017, 2018, 2019, and 2020. And what we did was we wanted to see if there was any potential temporal differences based on one charter region of the FIS. As you can see here from the figure, you got years on the x-axis and proportion of developmental stage on the x-axis. You can see that majority of the females have reached vitellogenesis stage, and there isn't much of a difference from those 4 years in the Portlock Charter region. The samples collected here in 2020 were, I think, a little bit later, early to mid-July, because the FIS that year was delayed due to the COVID pandemic. And as you can see, that a higher proportion of those females have reached VTG2 stage. But the rest of these are very similar in developmental. And then we also conducted a small spatial pilot study in 2020 during that reduced COVID survey. And what we did was we collected the same, we did 30 females, at least 90 centimeters in fork length in 5 different charter regions. This figure shows basically going from east to west. So St. James in British Columbia, Yakutat, Prince William Sound, Portlock, and Albatross. And one of the stark differences here, as you can see from the very far edges of east to west, we found a very high proportion of females in British Columbia during the sampling to be only in the cortical alveolar stage, so that had not reached vitellogenesis yet. So we would be determining as immature females. And then a lot more females, the farther west you went, developed and had higher developmental stages at the same time of sampling. So see here in Albatross, we had vitellogenesis 2, as well as some in vitellogenesis 3. So this kind of shows that there could be some spatial differences annually, as well as through time based on when females are developing into their cycle, whether they're in the eastern part of the stock or in the western part of the stock.
Was the sampling done at the same time across all of it?
Relatively, it was about end of July to beginning of August. So within about 2-3 weeks time span. The issue with this survey was that because it was delayed due to COVID, there was some delays in boats getting on the water. So we tried to get the sampling as close as possible. So using this information from these pilot studies, what the IPH Secretariat did was we wanted to conduct our first coast-wide sampling of histology for female Pacific halibut. In order to do this, we basically every vessel that was on the set line survey was going to be collecting histology samples based on where they were, where they bid for each charter region. So what we did was we sampled in biological regions 2, 3, 4, and 4B. We had sample targets, which equated to about 1,600 samples. Coast-wide was our goal. We did systematic sampling, which we felt was easier to implement in our tablet software system that the field staff use on boats. So what that means is that we calculated a maturity sample rate per biological region, as you see on here on the figure on the right. And so basically, if you were in biological region 2, so if you were sampling in, regulars 2A, 2B, or 2C, every 8th otolith that was selected for sampling, if female, they took a histology sample. And then if it was a male, they just skipped it, went to the next 8th otolith and cycled through there like that. And so using that sampling rate with the calculated otolith sampling rates for the fish that year, we were able to, calculate that rate based on the number of samples that we were trying to target. And so we're obviously going to be using this information to revise our maturity estimates per biological region, as well as coast-wide by histology staging. And then, as I mentioned earlier, our total targets were about 1,600 samples. We ended up with, I think, 1,016 is what our total number is. And you can see those numbers here by biological region. So we surpassed our sample target in biological region 2, collected over 400. We fell short in the rest of the biological regions, especially in particular in biological region 3, where we saw a drastic drop in catch rates for that region in the FIS last year. But we still ended up catching about 350 samples, which is still a really good sample size number. And then obviously in 4B, which was indicated yesterday, we do see a very high rate of males in that biological region. So basically they were on a 1-to-1 sampling rate. So they only caught 51 females last year on the set line survey, and they take a histology sample for every female caught. And so currently, we are processing these samples. The goal is to probably get them done by the end of this summer, and then start doing data analysis for revising of the maturity ogives by biological region and coast-wide. So these are just a couple of histograms that kind of show that our systematic sampling method is working. So here we have length on the x-axis and number of samples collected on the y-axis. And as you can see here, and I think I have a red line here. Yeah, so this red line is basically indicating 90 centimeters, which is what our knowledge is of female histology greater than 90 centimeters. So all of the pilot studies and all the reproductive assessment work that we've done in the past has been at least 90 centimeters or greater, because we were trying to only get what we would think would be mature females. And so here you can see that we've gotten a lot of samples that are less than 90 centimeters. So we're hoping that a lot of the histology we do have immature females. And that's still something that we don't know a lot about under the microscope. And so we're really looking forward to looking and seeing what immature females look at histologically. And then also here's another histogram with ages. And this red line is between 11 and 12 years. So our current maturity ogive in the stock assessment at 50%, age 50%, is at, I think, 11.6 years old for the female population. And as you can see here, we have a pretty good distribution of ages that were collected above and below that number. So moving on to our sampling for the 2023 FIS, which is actually currently ongoing. The boats are on the water. They've been on the water for about 3 to 4 weeks now. So due to the reduced sampling effort on the FIS this year, we're only able to collect samples in biological regions 2 and 3. We won't be getting any sampling out in areas 4 out west. So what we did was we maintained our sampling effort for biological region 2 as the same it was last year. So our hope is to get at least 400 histology samples. So we're just going to be focusing on maturity histology collections in biological region 2. And then in biological region 3, we're going to be implementing histology collections as well as fecundity collections for fecundity estimations. And so in order to do this, we currently only have 2 small motion compensated scales in-house. So we have 2 vessels, the Dangerous Cape and the Kimasu, who are going to be fishing, I believe it's 6 different charter regions within biological region 3. And they are going to be collecting fecundity samples on board and actually taking whole ovary weights at sea in order to help us do that. So we bumped up in order to get the number that we're looking for. So last year, I believe it was SRB20 in June last year, Joseph presented the autodiametric method, which is what we're going to be pursuing for fecundity estimation. In order to successfully build a curve for the autodiametric curve, you want to try to get about 250 to 300 sample size of about 250 to 300 to build that curve. And so what we're hoping is that by bumping up our sample size to 1,000 histology samples, we'll be able to meet that number for fecundity estimation. And then these are the 8, we have 8 vessels, and 2 of them will be collecting fecundity estimations out at sea. And then just this last slide to present kind of the generation of maturity ogives once the samples have been scored and females have been determined as mature or immature. We'll be using a logistic curve, a generalized linear model with binomial distribution, so either mature or immature, and a log-at-league function. And then we'll also be using the dose P function to determine proportion of mature individuals. So setting at an A50, an L50, or whatever we'd like, we can change those estimates for proportion of mature individuals. And then so the goal is to re-estimate our maturity ogives based on length and age coastwide and by biological regions based on the data that's available. And then also in the paper, as well as here, I've provided this link. So the IPH Secretariat is a part of a working group that was created by NOAA Fisheries called the Maturity Assessment, Reproductive Variability, and Life Strategies Group, which they've deemed as marvels. And we actually just had a meeting last May, which was in conjunction with the National Stock Assessment Workshop at Providence, Rhode Island. And we've recently built a GitHub page where people are creating a repository for maturity analysis information. So people that have conducted analyses in R and other methods, we're trying to combine everybody's information so we can feed off each other and how to conduct this stuff a little bit better. And with that, I'll take any questions.
Thanks, Colin.
So you have a seasonal distribution of maturity in that one spot in Portlock. But there's probably, looked like from your other one where there was a difference east to west in timing. Is that what that suggests, that the timing might be different?
Those are preliminary results based on a pilot study that suggests that there could be spatial differences in the timing maturity.
maturity?
I'm sorry?
Timing of spawning or age of maturity?
Timing might
Could
influence
be,
what
well,
you
it could be
interpret.
timing of the individual reaching maturity for that year, right? So you could have delayed development. So that preliminary results could be indicative that maybe individuals in British Columbia they're reaching reproductive potential for that year later. It's delayed development. And then potentially if you went farther out west, they might be developing faster, like reaching vitellogenesis faster earlier in the season. Yeah.
So you really can't do anything with this in terms of setting up developing region-specific maturity jobs because you don't know those individuals were simply going to develop eggs later in the season. It's a real regional difference in region maturity.
Yeah. I think so.
So is that
Age of maturity would be, you determine that by the proportion that were at a stage that couldn't make it by the spawning season. So that, I think we can delineate between those things to some degree. We expect to see some variability in which stage they're at among the stages that are going to reach maturity and spawn in a particular year. There's going to be early spawners and late spawners, and we can detect those. But then the second part of that is what fraction of the stock in different areas is at a stage that is too undeveloped to get there this year. So those would be either immature or skip spawning.
So those CA,
Yeah.
yeah. Those CA individuals, that high proportion of CA individuals in far eastern region, you're thinking that those will eventually spawn that year?
That's a question to be determined. We just don't, and it gets to the point with skip spawning. This was a discussion that I had with people at this Marvel group meeting. Other people that have done species in Alaska as well as in the Northeast. There's indication that there's potential for cold water species to be stuck in the CA stage. And that's happened for other species. It's just something that we don't know the answer to yet.
I think it's a little too early. I mean,
Yeah.
those results are based on 30 females. And those were generated in 2020. In 2022, we obtained 430 plus females from that same area. So we'll have a much better idea this year whether that trend holds and whether those spatial differences in the timing of maturity are consistent or not.
So the fitting of the region-specific logistic curves, that's not happening until you've solved this issue, right? It seems like
Well, all those females need to be scored first. I mean, that's where
Yeah.
Colin is right now. He's scoring all those 1,016 females that we have maturity samples for histology coastwide, and then establishing a coastwide maturity guide, but also region-specific maturity guide, comparing 2, 3, 4, and 4B.
But to get to the region specific, you really have to figure out first whether these eastern ones that are 40%, I think, in the CA stage are actually going to reproduce or not.
Well, in terms of scoring for maturity, those CA females will be classified as immature.
Even though they might spawn later in the season.
Even though it could be just a temporal thing, they may still spawn.
Yeah, I mean, you could generate maturity ogives at different times during the reproductive cycle
Yeah.
and get slightly different results.
Certainly makes sense that you would have an earlier stage, more northern you are, so it's not only just west, it's north, right? I mean, it's colder. And
But it was the other way around, wasn't it? That there were a high number of CA individuals in the east.
east/south.
Right. So they're earlier, even though it's warmer.
Later. Later.
They're later. They're less. They're less developed.
Less developed on the east.
They're more immature, according to those preliminary data, based on 30 females. There's more immature females in the eastern component of the stock of British Columbia than in the central belt.
Right, they're less developed at the same time.
More immature
In
females
the warmer area.
at that time of the year in July.
So it's just the clock is wound differently in different areas, north versus northwest, and southeast.
Well, remember, these fish are also likely making pretty extensive spawning migrations. So we've tagged some fish in Washington that went all the way to southeast Alaska during the spawning season. So it's also consistent with our vague understanding that fish migrate down the east side of the stock, and then as they hit maturity, they start making these spawning migrations.
So you've already
So
had
we
that
may have a
filter.
whole bunch of immature fish that are filtering themselves out to the east and south of the stock, and then as they mature, they start making these spawning migrations. So it's not surprising to see some geographic patterns based on the satellite tagging that we've done of summer to summer and summer to winter. That's how it is, so it's going to be complicated.
It's not changing sex along the way.
But you did bring up skip spawning. So skip spawning is definitely a area of research that we're looking forward to pursuing, because Ian is interested in what you would consider to be functional maturity. So biological maturity would basically just be taking what you would determine as mature, immature, building ogives, right? But there's been a lot of work using, I think it's like spline models and changing that asymptote on the top based on percentage of potential skip spawners. And that's stuff that we can determine with histology, looking at post-ovulatory follicles. So individuals that have shown spawning in the past that you might not think are going to get there for that year. They could have mass atresia events shown in histology that are showing that they're aborting, that they're spawning for that year. So that is definitely an area of research that we're going to pursuing with all these histology samples.
A conclusion from that initial study, the annual sampling of females that were all mature, of 380 females, I would say that possibly 5 were females that potentially were either skip spawning or what's referred to as abortive maturation. So females that enter the first reproductive cycle and then stop. So those are females that are clearly immature females, but they have not succeeded in completing the first attempt at that reproductive cycle. And it's very hard to distinguish those two. But just to give you an idea of what we found so far, it's 5 out of 380 females showed potential evidence for skip spawning. That's quite low so far, but we'll see.
Well, that's good. That kind of balance the potential. Skip spawning and suggests that maybe not a ton of resources need to be dedicated to understanding that because the scale of potential impact is pretty low.
Once the schedules are generated, and then we can look at ages for those particular females that are not mature at an age where we would expect them to be mature, and then look more closely at what features could be identified to move forward in identifying those potential escape spawning females.
Okay, well, let's
We
leave it
probably
there for
have,
this session.
Few more slides, I think a total of maybe 6 or 7. Probably it's up to you. We could break for lunch or.
I'm already 6 or 7 slides past lunch. So let's, we have an hour for lunch? So we'll come back at 2 o'clock? Sounds good. Long lunch. Oh, have an extra beer. I mean.
is closest to the mouse when I get you video on my
There was a question from Marie Chair. I'm not sure you want to address it now or.
Okay, well, we'll make a start. Could we just have the presentation up ready for Claude, please?
Anne Marie, do you want to ask your question now?
She's still coming, so let's hold the question.
Joseph, did you want to speak to this slide or are you good?
Are we ready to start? Yep. Well, just as an introduction to this research area, mortality and survival assessment, Claude will be presenting some of the results, the latest results on the characterization of these cards in the longline fishery. You may remember that we already reported on the estimates of discard mortality of this online fishery. Subsequently, Claude will present some of the results, more recent results on the charter recreational fishery. So go ahead, Claude.
Excuse me. So for the discard mortality work in the directed longline fishery, previously we've reported on the actual discard mortality rate estimate that came out of that. And since then, we've been tying in a variety of traits and conditions. So this is kind of just a schematic of how some of the data was related and analyzed. The elements in green here are individual fish characteristics, whether it be sex, size, body condition, physiological stress hormones. The brown elements are the traits of the environment that they were either in or exposed to. So things like bottom temperature, etc. And then we pass those things through the release methods that were used. Again, those were careful shake, canyon cut, and hook stripper. We identified all the injuries that the animals sustained and classified them via the viability categories that are used in the observer program. So looking at the hook release methods to the viabilities, again, this showed that for careful shake and canyon cut, they had virtually identical outcomes, essentially showing that the way the fishermen release these fish is causing no more harm than if the canyon was simply cut and the hook was left in it. Essentially, it's very similar to the hooking injuries. But the hook stripper caused much more severe injuries with far fewer excellent tabbed fish and a lot more moderate and poor, particularly when you're looking at sublegal fish, which are in the right-hand column here. So those sublegal fish have much poorer outcomes when they're not carefully handled. And then looking at the actual injury sustained, I recognize this is hard to see on here, but these are essentially, again, legal on the left, sublegals on the right, and the injuries in increasing severity from left to right. But for the two regulated release methods of gentle shake and canyon cut, roughly 80% of the fish just have that simple catching injury, that torn cheek, which is a small hole through the cheek, and with small degrees of the other ones, whereas that hook stripper starts to have much more tearing injuries, and particularly in the smaller fish, you get those torn faces. And these are the fish, again, the sublegals of the fish that are kind of the focus of the study, because they're the ones that the fishers are required to release in the fishery. So we're interested in understanding what's happening to them and what's giving them the outcomes that they have. Previously reported was a minimum discard mortality rate of 4.2%. That was previously reported by Laura et al. Looking at the stress indicators in the blood for glucose on the upper left here, and this is by viability classification, and for cortisol. we didn't, we saw broad kind of individual variation within a category, and we didn't see any significance in between categories. However, for lactate, we did see that dead fish had significantly higher amounts of lactate in them, and they also had a lower hematocrit. And sorry, we believe those two are both tied to amphipod intrusion or sand fleas. So when an animal has a sand flea intrusion, we know from previous tagging studies that they generally don't have a very high survival, if any. And this would be being covered in amphipods, we hypothesize would cause those lactate levels to go up. The animal will continue to struggle on the line as it's trying to get away from them. Its lactate levels would go up and it wouldn't have a chance to clear them before it was sacrificed. Or before, in this case, it wasn't being sacrificed. It came up the surface, had its blood drawn, was tagged and released. And they also had that lower hematocrit, which would be also coincident to blood loss being caused by sand fleas. Sorry, so that's the end of that characterization on the long line study. Moving into the recreational discard mortality study. These two slides were in response to a request from the last SRB meeting asking for some maps of some of the tag data. Two types of tags were released in this study. 80 satellite tags were released that gave us a mortality rate estimate at the end of that part that we've previously reported as 1.35. Those satellite releases and recoveries are shown here, and all the satellite tags were released on the Seward leg of the work. We did two legs, one out of Sitka, one out of Seward. And so for the wire tagging, the majority of the results are showing out of Sitka, because that's where most of the wire tags were released from. After 2 years of data collection, this data effort happened, or the tagging effort happened in 2021. And we've already received 32 recoveries to date, which is just over 11%, which is quite high for wire tagging studies. Often we are lucky to hit 10% after kind of a 5 to 10 year span. So we're seeing pretty high recoveries of these tags. A lot of them are being recovered right on the sites roughly where they were released, but there are some larger movements that are happening. And in the text, I described this, but D tags are wire tags. I should have done a different legend here. And S is where satellite tags. So 7 of the satellite tagged fish had recoveries before the satellite tags had fully completed their job and popped off the fish. They were recovered in the recreational fishery, and we were able to receive those tags here and fully download those. Any questions on that?
You had a table, table 3, you had distances summarized, and I was really curious, why do you think there was such interannual variation of the average distance traveled?
Yeah, so that's a good question. I put that data in table 3 on page 13 of the report that goes with this. And I was surprised by that too. I actually thought particularly in the wire tags in area 2C, I thought the first year we'd see less average distance traveled. And as the tags were at large for longer periods of time, we'd see farther ranging recoveries. It's actually the opposite of that. We had roughly half the tags each year were recovered within 3 miles of their release, which from the FIS perspective is back on the station you released them on. But I don't know why that happened, and I'm kind of curious to see further tag recoveries to see if we continue to see that. Certainly on the pit tag study we did in 03 and 04, it wasn't unusual on our survey vessels to recapture pit tags on the same station that we released them on. And there was just a kind of a general broadcast of those as well over the next 2 to 3 years, but it was hard to pinpoint unless you were on survey the exact location that a commercial vessel. So I don't have a good answer for that. It could be related to that's the range of their summer feeding grounds. we could also look at it as those tags start to be recovered. We can look at how they relate to the viability that was assigned to them and the injuries that were assigned to them. So they have to go further afield with certain facial injuries to acquire the food they need, or things like that. Although we saw less variation in injury and in vitality in the recreational, like we can get any fish, very few poor fish. But almost all of them. I think it was 95% were excellent condition fish. So there's not a lot of differentiation here for them. So then moving into the catch protection study, this is a study that we've been doing for a couple of years now. It started with an effort to reach out to experts in the field that are dealing with whale depredation, trying to better understand what are the best ways to kind of stop the cycle of reward in the behavior. So preventing the whales from getting that reward at all. And we held a workshop in 2021, and that identified shuttles, so like an underwater device that contains the fish from the bottom of the ocean up to the surface, or a shroud, which is a device that essentially cloaks over a cluster of animals and kind of interferes with access to it on the way to the surface. So we took the results from the workshop, honed in on 2 devices, the enclosed shuttles and the shrouds, and we wanted to do some pilot work with them on the smaller vessels seen in our fleet, looking at both deployment and retrieval logistics, the best weighting and performance configurations, and to look at some basic performances of the devices on species being caught, sizes of animals being caught, and how well the devices performed. So we did this field work. Ian was out with me the last week of May. We had a partner with us from Norway, who's the designer behind the shuttle device. And we had a partner from National Marine Fisheries who provided help with attaching cameras and other sensors on the devices to better kind of describe their performance. But it doesn't show up so well on here, but these shuttle devices slide down the ground line with the open end here. And as the ground line comes through it, fish are, the ground line and hooks pass through the device and the fish are unhooked inside of it. It then hits a stopper after a predetermined time and it rides up to the surface, bringing the fish inside the container. So these are some imagery from that field work. So the device, we had 2 of them. These are reduced in size by about 80% from the devices that are currently being used by this Norwegian company in the toothfish fishery in the Antarctic oceans. So this is it when it's sitting on the vessel, gets deployed over the side and gets threaded onto the ground line. And it slides down the ground line to the bottom of the ocean, plucking fish off near the kind of bottom ocean interface. Once it's full, it rides the stopper back up to the surface. This is it coming back up from the bottom. The water drains out of it. And you can see the fish entrained inside of it. It has at the front here, it has a flip door that we open up. There's a trolley masquerading as a flat, as a Pacific halibut right here, but this was a pretty clean tow, mostly a Pacific halibut. And you keep that door open and they just spill out onto the deck and you can sample them. So that device worked quite well. It took a bunch of kind of logistics to figure out how best to thread it onto the gear. Traditionally, these things have been fished at the bottom with their gears. They send one down with every certain number of hooks and have fished them there. And so being able to thread it on from the surface when you need to use it is a new kind of thing. And it requires kind of some fancy rope dances that once we had it figured out, worked quite well. There was a real learning curve there. And it was good to have the kind of inventor there with us because trying to describe that in a second language would have been challenging. But we've got, we'll be able to write up the description of that pretty well, I think. And in this image, you can also see we had a tip and roll sensor attached. We had some cameras inside the device that'll help us better understand some of the performance metrics where some of them not making it into the thing, were they hitting the front and peeling off to the outside, what animals were going through it, those sorts of things. The shrouds, the concept here is to fish something called a branch line. So you have what's known as a mother line, which is really a ground line with smaller ground line branches coming off the side of it. In our case, we had 10 ganyons snapped to this with the hopes that we had less grippy snaps at this end and more grippy ones on this end, so that as the shroud slid over it during the haulback event, they would slide down together, cluster up, and the shroud itself would cover the fish up, kind of like that. So we made these from modified slinky pots. So we put a cap in one end with a small hole in it. We completely opened up the other end and we put a ring around it to prevent the hooks from getting caught on the edge of it as they flowed through. You can see one of our camera devices inside the device here. These were being set so the branch with its 10 hooks and bait would go off this side of the chute. Once they were mostly over, they would launch the shroud itself. This turned into an interesting learning experience where we had worked with a bunch of fishermen out of Chile who regularly fish branch lines, and they described it to us. We drew it up, explained it to the fishers. Then there was some elements that you just don't understand about fishing when you're sitting at your desk. And there are certain distances that they keep in their gear for safety that are void of hooks, void of weight clusters, things like that. And it ate up a bunch of our spacing that we had anticipated fishing. So we ended up having to fish our hooks instead of 4 feet apart. We fished them 2 feet apart in this case, and ended up having, 10 hooks over 20 feet, whereas our normal fish gear is 1 hook every 18 feet. So it really shrank our footprint for fishing. But we learned how to weight them properly, how to attach them, and all those good things, which was one of the goals of the work. Here you can see a device coming back to the surface. It's a little hard to see in here, but all the hooks were successfully sliding together and clustering compared to the way they had been at the surface. You can kind of see it zoomed in on it here. The catch rates weren't as high with this, again, because of that smaller footprint. And we also were having some challenges with hagfish in this area, to the point we actually caught hagfish on hooks, which was a new observation for us. We've never witnessed that before. So, any questions on that stuff? The data's about to be key punched here so that we can start looking at catch comparisons and some of those preliminary things.
So the goal here was not to look at reductions in depredation whales around.
That's correct. We purposely did this without whales being around. We would have had to have shut down if there was whales present at the time. We didn't have permits to do that. We have applied for further grant funding to pursue that if this pilot stuff showed that vessels of this size could successfully deploy the unit, we could actually get halibut to go into it and remove them in there, that we would want to do a larger scale study in the presence of whales. We're waiting to hear back on the results of that. And that would happen in known whale hotspots in Alaska. And it would move on a step from the pilot work. I'm sure it would still have elements of that you kind of got to adjust as you're on a new boat, but it would be looking a little more at the catch differentiation between control when there's whales there and the unit, the treatment. But also one of the standard criticisms you get is essentially you're using a hook stripper inside this device in a sense to remove the fish into the device. And we learned pretty quick on this work that the ganyons and the hooks used in the commercial fleet may have to be adjusted. Those are designed to capture fish at the bottom, retain it on the gear, and bring it all the way to the surface in rough seas. And you probably don't need as stiff a ganyon or as heavy a hook to retain the gear on the bottom if you're going to be popping it off. And we actually used, partway through this study, softer ganyons and softer hooks, and immediately saw a reduction in the damage to the fish. So there's interest there, because right now the regulations say you got to release all your sublethal fish, minimal injury. So we got to be sensitive to that issue of bringing up fish this way.
But that means you have to know at the time you set your gear
that you're in it. Yeah, but some of these guys are fishing in areas where they're regularly getting whaled on. They're interested in that.
That's sense. There's going to be a whale boat.
And I'm super interested too that the Antarctic stuff showed that they're actually losing fish on the way up to the surface, even when there's not whales there. And they were assuming they were bringing up everything, but when they use these catch protection devices, they're bringing up larger fish than they do when they regularly fish. So they're losing some of those larger fish in their CPU documentation, just in the course of fishing, and they're realizing that now by entrapping it at the bottom, that they're getting a better picture of what was really up here. Not to freak Ian out about his estimates of retention to the surface.
Before you go on, just one last thought about the discard mortality study. So, can you go back to that?
The long line or the red?
Slide on the recreation discard. Yeah, here. So you've got the mortality rate estimate for the excellent category.
Correct.
And you've got the wire tags that I think can give you the different return rate by category. So have you tried to use that to figure out what the discard mortality rate is for the other categories, not excellent?
That's how it's been done in the longline fishery. This has never been done in the recreational fishery. So I don't know that we'll get enough data from this one simply because the numbers of fish in moderate and poor categories are very low.
How many of those 32 are from 32 recovered are from the moderate?
One of them is from the moderate.
How many?
The rest are all from excellent.
How many of the 281 are from moderate?
I want to say it's a combined between, I think it's 11 moderate, 2 poor. So it was hard to get them into that condition. Like you almost had to artificially do something to them to get them in, you know, which is a compliment to the fishery itself. But there's also the reality of they knew what we were trying to do with this study. And is there a higher encounter rate of moderate and poor in the fishery? Likely to some degree, particularly in the unguided fishery. If you have new fishers going out who don't recognize when they have a fish on the line and that are more prone to getting gut swallowed. Whereas here, you know, the guides are very quick. Hey, you got a fish on, right? Like they let you know right away. I could envision that there's different rates between guided and unguided to work out some of those. But that is also a function of the previous study, the long line one, where we have many more that are in the moderate poor and dead category, to the point that one of our tag recoveries in that fishery now was a dead fish. So he was diagnosed as dead. He had a pretty torn up face and had sand flea intrusion. He was recovered last year, 4 or 5 years after the study. And we call those Lazarus fish colloquially in-house. We've seen it in the trawl fleet before, where a fish is heavily beat up, full of silt, things like that, in its gills, and it's categorized as dead and has sand fleas. And we've had recoveries of those a couple times. We haven't seen it in the longline fishery, but now we have. So even though, and people are like, why are you tagging that?
I mean, even with those low, even with those low returns, I think that could probably help you bound the mortality other than excellent categories. If you lumped it with other than excellent category, and if you apply those rates overall, you probably use that to get a decent overall discard mortality. I know the rec sector in general is small anyway, so it's probably not a big impact on the assessment, but I think that is the link to the assessment then, right? If you can do that. Right?
It's not that small. It's 15% of the total mortality, so it's fairly sizable. The challenge we have is we don't, as Claude was saying, we don't have a good estimate of the viability, the distribution of viability categories that are occurring in the general rec fish because there's so much going on. There are also some other gear types used, J hooks versus circle hooks, jigs, other things. So we'd still be a couple steps away from putting it all together, but you're absolutely right that that's the method, using anchoring in the excellent category and then using relative tag returns to get the offsets to the other categories.
So that was the plan.
Yeah.
And this is a summary of the grants that we've had involved in these my project and Andy's project.
Oh, you could have done that.
Was there one more?
Sorry. That's just the last one. So the SRB to note the paper and the presentation and take in questions.
One more, the fishermen feel about these preparation devices, were they just shaking their heads like this is never something we're going to use, or sense that they can figure this out?
No, I had a sense that they could figure out, they were pretty interested in it. We did 2 days of dry dock work, kind of prepping some of the gear and trying to understand how we were going to thread that thing on without losing all of our gear. And there was a steady stream of other fishers all walking up. What is that? What is that? You know, it's a bit of a Jules Verne looking thing strapped to the side of the vessel, and there's one on each side. And everyone's like, what is that? You can put halibut in there. Good luck with that. And, you know, we got fairly large, big skates and long nose skates that go in there. They're a little more bendy than the halibut are. And so that was encouraging to the guys. They were surprised at what was getting in there. I think they thought a lot of stuff would get flipped off on the outside before it even entered. We had some small petrale that went right through it. We get them on the other side. So we had some observations like that as well. And you don't, originally we were like, oh, you know, you could just let all the sublegal, so you could dial in that keyhole thing and let the fish go through. And then we're like, no, we can't do that, because then we're still rewarding whales. We need to just completely not have that happen. And the Norwegian guy behind it, he had a lot of ideas on how to reduce. Right now, he's in a fishery where it's full retention. So he's not worried about the damage being done to the fish as they're being removed from the hook, because he has to keep them all to get the surface anyways. But, you know, he had exposure to other kinds of gear that we're not even familiar with, that you could have this ball and cup thing that the hook's on this end and it just pops off the cup and goes into the device. And so it's now got an earring hanging out of its mouth kind of thing. And then you unhook it at the surface, and then you just pop these back onto your gear that's hanging on. So, and they were pretty clever at coming up with ways to more safely set the shroud gear. Hauling the shroud gear may still be tricky unless you have a drum. There may be some specific vessels that works better on. It's certainly used by the Chileans a fair bit. And they have a lot more branches on their gear. But I think that needs some more dialing in if we want to pursue that. Shuttle definitely has a lot of problems.
So the next proposal is going to focus on the shuttle.
I think so. We wrote it generally enough that we can look at both, but I think the best way to do it would be to do that. We could also have commercial gear that for the control gear, we could probably have gear that also mimics the FIS. We can get extra data from the FIS at the same time. I'm trying to think that way as ways to do two projects at once and enhance our data set. So
We're going to SK with the
that one we've approached perhaps the bycatch reduction and engineering program, which is the main funder on it currently.
Well, this completes our report.
Thank you very much. Now we'll move on to monitoring. Ready around?
It is. So we have him until 4. We just wander down. Ray, can you hear us?
See if Henry's back.
Yeah, would you want to address Anne Marie's question?
She's there.
Yeah, she's typing.
Oh, she's here. We unmute her.
Okay, there we go.
There we go.
Um, yeah. Do you just want me to read over the questions again, or?
Yeah, maybe you can just say it. We can't really see the question. But
Okay, yeah. So I think there were basically two broad sort of concerns in terms of like the context. One was around the financial cost viability of the FIS, like in the longer term. And then the second one was concern around the changes that are made after you guys see it and the one that's actually approved by the time we get to the annual meeting, and what sort of cumulative effects in terms of scientific viability that has. And then I guess the general question was around like the general question was around what sort of things could be done to help with those two things. I think two of the things that were flagged was either changing the target CV from 15% or doing something in terms of the design of the stations. I think there's also an underlying concern that I heard from at least one of the commissioners in terms of it feels like to them that they're making some pretty big changes from the design that you guys approved. And so, is there a way to essentially bake in a design that incorporates some of those secondary and tertiary concerns so that it's more of a holistic design, I guess, that everybody looks at and can sign off on or check off, and not just sort of leaving it to the commissioners at the very end.
thanks. I was actually interested in the question that you had about, didn't you have a question about the maturity ogive?
Oh, that one. Sorry.
Well, I've heard all this before. I don't think that's what it
Well,
is.
I know. Well, that's what I was asking, because it's like, well, there's the FIS design right on the thing.
Recap of your question.
Yes. So, I can't. Is it Andy who was talking? Anyways, there was someone who was talking, and they were presenting on the maturity ogive as the very last slide, and I was wondering about the ETA of that and when the maturity ogive would be available, when it would be incorporated into the stock assessment, and that is in context of the point that Pete raised yesterday in terms of being able to prepare the commissioners for upcoming changes in the stock assessment.
Thank you. Yeah.
Yeah, thanks, Anne Marie, for the question. This is Giuseppe. We expect that we could probably have those maturity schedules by the beginning of 2024. That's the plan. So those coast-wide and then region-specific maturity archives would be available for Ian in the early spring, possibly for incorporation into the, but I'll refer that to him. We could have at least the maturity schedules computed by the beginning of 2024. Let's say that.
Yeah, so as Colin showed, we haven't quite hit our sampling targets the first couple of years for a variety of reasons. So we're anticipating it may take at least this season to get the rest of the samples. I think it's conceivable that we might even need another year of sampling. In terms of on the assessment side, it really is going to depend on how different these estimates are from the visual estimates that we're currently using. I would say if the results of this study show that we're pretty close with our current maturity schedule as visually assessed on the survey, then that's something I could probably integrate into an updated assessment, perhaps in 2024. But if we find something that's very different, we may want to hold that until the 2025 full assessment and really evaluate, really look at it thoroughly before we make a major change to the assessment. So my hope would be that we would be able to stick to the current assessment
timing, which would be updates, presumably with no major changes this year and next year, and then a potentially bigger reevaluation in 2025 and a change if needed at that point. Because the challenge in all these things is that they may or may not have a big effect on the assessment. You know, we could do a lot of work and find out that we're doing about the right thing right now, and it doesn't mean we shouldn't have done the work. It just means that we had about the right estimate to begin with.
Briefly, how would you combine region-specific?
So I think the way that I've dealt with this and the way I deal with the age composition data is to use the density estimates from the space-time model as our best proxy for the distribution of the stock. And so you basically just do a weighted composite for example, for a coast-wide assessment. You have to aggregate across areas. And I would weight those by our estimates of numbers, fish in each region. And that would allow us to have an unbalanced sampling design. You know, if we sampled in proportion, in the same proportion across all regions, we could just naively pool the samples, but we're not trying to do that in this case.
I think you're still worried about achieving the sample sizes when I raise the sampling rate.
There's already one in the West where we're probably going to have the lowest.
In the West, clearly there's no room,
Yeah.
but the other ones, they were like 1, 3, or.
Yeah, this is a pretty big add-on to the survey tasking already. They are already busy. And I know, Colin, you could probably describe what it's like to ask them to collect 1 out of 3 fish.
I will say, going into last year, there was concerns. I was on the FIS team before coming to the research branch. So there was concerns about overwork of the field staff on board and the task. But we did come to find that the histology sampling on board really isn't that much of a task. It doesn't take much time. This year we are also incorporating fecundity. So they're doing they're doing gonad weighing on a couple of vessels as well. And I think potentially over time, we'd like to expand that to more vessels every year. So it's a great question. And there is definitely a balance there, trying to get the sample size that we want, but not also destroying our field staff on the boats, right? So I think what we're trying to get right now is a good number. And the FIS team that I used to work with is comfortable with what we're trying to target. So.
Is there variation in egg size? Does weight really give you number of eggs? If there's variation?
Well, the method that we're trying to use is you need the whole ovary weight to extrapolate out to potential annual fecundity for that fish, because the autodiametric method is taking the mean oocyte diameter based on a subsample of the whole thing, building a curve, and then being able to extrapolate that out to the whole ovary. So you need the whole weight to do that.
Constructing a curve.
Yeah.
Okay. Well, I think you good with that answer, Anne Marie?
Yes, thank you.
Okay, so let's move on. Take it away. Great.
Okay. Do I maximize this? All right. A lot of this is going to seem familiar. I have basically the same introductory slides each year because I make the assumption that people may not remember some material and maybe new people on the board, which there's not this year, but for new people tuning in. So start with the introduction. Okay, the usual background, the history of the FIS, a little bit on space-time modeling, design objectives and the review process, and then the proposed designs, evaluation and revision of designs, and consideration of costs. So the FIS most important source of, can I make that go away? The most important source of data on Pacific halibut provides data for estimating weight numbers per unit effort. used for estimated stock trends and stock distribution, both of which have already come up in this meeting, and has its importance as an input into the stock assessment, and provides biological data for use in the stock assessment. We've conducted a standardized FIS each year since 1993. The coverage was limited in the early years, mainly to the core part of the stock, 2B, 2C, 3A, and 3B. The modern FIS design is on a 10 by 10 nautical mile grid, and that began in 1998. By 2001, we had annual coverage in all regulatory areas in depths from 20 to 275 fathoms in most of the range, and 75 to 275 fathoms on the Bering Sea shelf edge. By 2010, we realized that we weren't covering all Pacific halibut habitat. We were missing those deeper and shallower waters, and also there were coverage gaps in the depths that we were sampling throughout the range of the stock. So there was a potential for bias in estimates derived from the FIS, and so we undertook a series of expansions over the period 2011 to 2019, covering previously unsampled habitat. And by the end of that, we'd added full 34% of the current footprint of stations to the grid, and we had an improved understanding of density and distribution, reducing bias, improving our estimates of uncertainty throughout the time series. And now we have 1,890 stations to choose from each year when we're coming up with a FIS design. We can't sample all 1,890 stations each year, much as we would like to. We don't have the resources for that. It's become increasingly apparent. These are what those stations look like. They're the orange points on the map. We also make use of data from the NIMS Troll Survey, the blue stations. That's the typical footprint these days, with the extension of the survey up to the Bering Strait over the last few years. We use a length-based calibration to convert the NIMS Troll catch rates into FIS catch rates, and we also make use of the Alaska Department of Fish and Game Troll Survey data in Northern Sound, the red points there, and that is in recent years also been an annual survey. They don't catch a lot of halibut, but it's in an area which, at least in the past, we didn't have a lot of information, so it helps with the time series for the Northern Bering Sea in particular. That survey was actually not undertaken in 2022 because they had difficulty getting a suitable vessel, or their usual vessel. There was some issues with that. But I'm hoping that they're back on water again this year. So guiding sort of table for designing these surveys is this. We have our primary objective, sampling the stock for stock assessment, stock distribution estimation. Secondary objective, long-term revenue neutrality, and tertiary objectives are basically minimizing the impact on the stock, assisting others in collecting data, and so on. So the main factor for the designs that I'm presenting today, the main consideration is the primary objective, meeting our scientific needs. Although there is some consideration of secondary objectives in the type of designs that have been presented in the last few years. Okay, the review analysis timeline. Consider the process starting in March after the annual meeting is completed, where we develop and revise designs for the next 3 years prior to presentation to you folks and at the June meeting. Between our June and September meetings of the SRB, the data are being collected on the water. You may have some suggestions for further work. I suspect that that's going to be the case this year. So we can work on revising things before the September meeting, but in particular, the next chance that anyone will have a look at these designs for next year, coming years, will be the commissioners at the work meeting around the middle of September. After the completion of the SRB, the FIS data will be finalized. Add that there. So that just to emphasize that all analyses up until then are based on prior year's data. So my analysis for the designs for 2024 doesn't have any data from 2023. It's just part of the timeline we're working with. Those data are not quality control checked and available in the databases until usually early October. The commissioners make a decision on the preferred designs, endorse some designs going forwards, and there may be adjustments to those designs at the annual meeting. And throughout the process, we have feedback from stakeholders, particular vessels that were skippers and crew of vessels that were involved with in this charter process. But also we get a lot of feedback at meetings, like the Research Advisory Board meeting. There's certainly stakeholder feedback at interim meeting and the annual meeting about designs. But there's plenty of opportunity for people to get in touch with us formally or informally throughout the year. As new FIS data come in each year, we revise our understanding of the spatial distribution of the stock, local contraction or expansion distribution, or changes of interannual variability in subareas. Talk a bit about what subareas are in a bit. Can lead to revisions in the timing and frequency of FIS sampling. So while we're putting forward designs for the next 3 years, we expect that designs following the next year will be revised as more information come in. And so changes in the variability of Pacific halibut catch rates among stations can affect the number of stations proposed. Changes in the proposed designs to account for secondary and tertiary objectives will also affect design proposals in subsequent years. That's a new bullet point, and it's become particularly pertinent in recent years as the cost of implementing the FIS has meant that the designs that we propose, based on principally on scientific considerations, are modified prior to implementation due to largely the cost considerations. So if we're not able to fish all the stations that we wanted to meet our scientific objectives in 1 year, then that's going to affect the designs that come the following year, where we may desire to catch up on what we missed. So this was the proposed design that you saw in 2022 for the current year. And so we had a proposal for 2020. I'm sorry, yes, that's right. Yep. Okay, so this was the design that you endorsed last year, where we had fishing in the far western Aleutians and the central Aleutians in 4A, 4B, stations all along the Bering Sea shelf edge, random selection of stations in the core of the stock, and quite comprehensive coverage in 2A from Northern California up until the US-Canada border, 2A. Okay, what is actually being implemented right now in 2023 is quite different. So I can flick between these a bit if you could, but they're not quite on the same scale. But you see, basically, almost all the sampling is gone from area 2A, except for a cluster of 16 grid stations, supplemented with 8 rockfish index stations. They're not part of the station grid that I work with, but they're data. They provide data. In 2A, almost 100% sampling in 2C, almost 100% sampling in 2B, except for the inside waters of the Strait of Georgia, Salish Sea. 100% sampling through most of 3B, except for the far west, where we have the random sampling, and 100% sampling of some FIS charter regions in 3A, the ones that make money. No sampling in 4A and 4B on the FIS grid, or 4CDE. Those are those are our most expensive regions to sample. The commissioners did endorse a design which had a small number of stations near the 4A, 4B border, but we were not successful in getting bids for those stations this year. We will have Stroll survey data coming in again this year, and those stations are marked in a sort of lighter orange in the Bering Sea. And hopefully we have some Alaska Department of Fish and Game stations as well in Northern Sound. So we will have extensive coverage in the Bering Sea regardless, calibrated using our standard calibration methods developed when those two surveys had overlap with our survey. But no fish sampling directly itself. So quite a change from what you endorsed at your two meetings to what was, and somewhat of a change from what the commission has endorsed initially at the interim meeting as well. As I mentioned, scaling back from that meeting, 4A, 4B, and I think we have deleted 2 charter regions from 3A since then as well. Okay. So, you're probably thinking along the lines of some of the questions that you've already had from Anne Marie and others about how it may be beneficial for you to have some chance to weigh in on something that's closer to this prior to the commissioners seeing it, so that you can have some scientific input onto this. Otherwise, as it's been noted, we give our own feedback to the commissioners, try to give them a sense of what the risks involved are in going forward with a design like this, scaling back the stations that were proposed. But it seems that there's a desire and there'll be benefit from you being able to have some input as well. That would require us to kind of anticipate what's going to happen, and maybe Ian may be able to talk about this later, but there may be a chance for us to do that as we get a better understanding throughout the season of what prices are going to be like, what costs are going to be like in the coming year based on how things are progressing this year. There may be a window in September for us to come up with some ideas of where commissioners might land prior to your meeting at the end of September. But that's certainly something that we can discuss. We should discuss. So the proposed 2020. So leading into what I'm proposing here for the next 3 years. Why we're proposing that based on scientific needs and what we're missing this year. So the proposed 2024 design includes sampling in regions that we had proposed for 2023, but we're not able to do. One other change from last year's 2024 proposal was to bring forward sampling in southeastern IPHC regulatory area 4A, and you'll see why in a moment. The proposal also includes random sampling of stations in the core of the stock and sampling all standard fish stations in regulatory area 4 CDE, which we propose on an annual basis and which you have supported in your comments previously. Highly dynamic area with apparently northward shifting distribution, uncertainty regarding connectivity with near to and within Russian waters. And we note that complete sampling did not take place in 2021 or 2022, although over the 2 years combined, we did sample all stations, and that no sampling is taking place in 2023 on this, but we will have data from the Minstrel survey. So this is the proposed 2024 design. It's like I'm going to have a bunch of highlighted things showing up. So this looks a lot like the 2023 design that we had initially proposed, with a different randomization of stations from 2B to 3B, but bringing back in the Western Aleutians, which we have not sampled since 2019, the Central Aleutians, which we haven't sampled in. Well, I think I'll be stepping through that in a minute anyway. But as I mentioned, the southeastern part of 4A, which hasn't been sampled in 2019, and we've got reasons to think that this is something that we should be looking at sooner than we had previously anticipated. And sampling in 2A. Let's see what this does. Okay, so these green boxed areas were proposed in 2023, but not sampled. So based on our scientific needs then, those needs still apply now. And so we're proposing them for sampling as soon as possible, which is 2024. Now this box in blue was previously proposed to 2025 last year. But we bring it forward to 2024 because of concerns about the potential for bias through not sampling that area for an extended period of time. And I'll talk more about that. So the 2025 FIS design looks a lot like what we proposed previously. But one change is we had proposed the southeastern area. We're switching that with that area. This is now the data indicating, the analysis indicates this is more of a priority. So this area, which does have some sampling, a little bit from a few stations from the troll survey, as we get here, some data, but is otherwise relatively stable, is being pushed back to 2025. And 2026 is essentially sampling the core of the ends of the stock again. This is kind of like what would be the standard design, where we're sampling the core part of 2A, the densest part of 2A, the densest part of 4A, and the densest part of 4B, which provide us the most information, at least based on our current understanding of the stock in those regulatory areas. So we've talked a bit already about coefficients of variation and the target coefficients of variation currently being 15%. For a little bit of history or context, this 15% value came up well over 10 years ago when we were having discussions mainly about 2A, and 2A being a part of the stock that seemed to be more variable, and we had less precise information on catch rate indices in 2A than we had in other areas. And so at the time, we had some discussions, stakeholders and tribes in 2A, about how we could improve the survey there. Adding, and one idea was we have a denser grid in parts of 2A to bring down the CV to get more precise information in line with other parts of the stock. And so when we were developing criteria after the survey expansions were completed, the 15% number came back again as a way of maintaining the quality of the data that we had previously. So it was ensuring that whatever we're doing going forward maintained the levels of precision that we had been maintaining and previously. So certainly open for discussion whether that number continues to be appropriate, and it really depends on who you are, with who you, and at what level you're analyzing the data, whether this is the number you. Yes.
So this is kind of getting similar to the conversation that we had about the NSC objectives. Target range is less than 15%, but some of those are way less than 15%.
Correct.
Is there a way that you can tune them all so that is it a discrete thing, like you either get 9 or you get 15, or is it somewhat continuous? Like, can you find designs that target them all for as close to 15% as possible?
So, and this is on the outside of the stock. Some of the core areas have CVs down to 3 or 5%.
We were talking yesterday that, yeah, once you roll all this stuff up to coast wide, you get something really small.
Yeah, it's like 3 or 4. Yeah. So this is, we don't need CVs of 3% in the 3A, but it's part of the nature. And I think this is one of your comments, that this is a large area. We're going to have a lot of stations in a large area. It doesn't matter the geographic size, the number of stations is what drives the precision. And so it's always, if you're sampling at a high rate, relatively high rate, you're always going to have a much lower CV in areas with a lot of stations. Those areas, though, are the ones that fund the survey. So we can't really cut stations out in those areas because we don't statistically need them. So setting aside the core of the stock, which we need for making money, can we live with a higher CV? Is it a way of fishing a survey in 4A, say in 2024, which gives us a higher CV, but still meets our data needs? And one of the difficulties with going to somewhere like 4A, I mean, maybe, the answer is maybe, but one of the difficulties of somewhere like 4A is a lot of the cost is getting there in the first place. And And so cutting down your sampling, thinning the sampling, or just sampling in bits and pieces of the part you want to do may not save you as much money as you would like. So we're talking in 50s, 60s. I think it's 59 stations in 4A. Is the core part of 4A. A proposal is larger for 2024, but if we're to tackle these subregions, there's some constraints on how much money you can save by reducing that. I mean, we could try to spread. Let's go back to the design. So I came up with, we devised 3 broad sub areas basically per regulatory area. So the highest density, most likely to change with time sub area, and then a couple of secondary sub areas, which in the past have had varying proportions of the area's biomass, higher in the past in some cases. But there's nothing stopping us from breaking this down further. And in effect, the commissioners did this in the interim meeting where they picked a design that attempted to sample the core of the core, 16 stations on the 4B side and 16 stations on the 4A side right here, which is where the absolute highest densities have been. It was, it's not ideal in conjuring a picture of what the stock's doing across the regulatory area, but it's something.
Although what we learned was that vessels won't go that far to sample 30 stations.
Right.
Nobody wants that work.
Yeah.
It
So-
takes more stations than that for someone to drive all the way out west.
Indeed. So that's where
And we
we're
did
hitting,
warn them of that. That was a
we're hitting
potential.
those constraints, right? On paper, it looked like we could afford to do that. In practice, nobody wanted to do that. But if we added more stations, then we might have got some bids, but we wouldn't have been able to afford those vessels with those bids.
Because
So
the
it-
catch rates aren't high enough out
Catch,
there.
catch rates are not high enough, and the high costs are getting there. And I don't know what,
It takes a lot of time. People
Yeah.
have a lot of sablefish to catch. They don't necessarily want to take a month and a half.
I mean, in reality, the catch rates are actually quite high
They are.
in Western 4B and Eastern 4A, comparable to other parts of the stock where people are making money, but it's just much more expensive to go out. So, we can look at reduced designs to meet a target CV, but I'm not sure how far that gets us in having a survey that we can actually run, that we can get bids for, and how much money we end up saving by doing that.
Last year, we talked about opening up
Yeah.
snack here.
And we are doing that.
And that didn't get any bids because of these 30 stations.
Did anyone consider that?
We have one vessel doing how many charter regions with Snap Gear? Two charter regions. So we did get one competitive bid for Snap Gear this year,
But
But
wasn't-
it was in the
but it
core
wasn't
of the
out
stock.
there.
It was a place we probably would have got a bid anyway, which is maybe more expensive, but nobody's, the possibility of fishing Snap Gear didn't help.
That's also new, and it's quite possible that not everybody in the fleet knows that we're doing that yet. It may take some time for that information to filter out. As hard as we worked this year to promote that and announce it, things move slowly. Not everybody's on the internet checking our website. So
This design looks really expensive. It is actually revenue neutral.
No, because we haven't, well, I'm leaping in saying, no, it won't be. I'm confident
Yeah,
it won't be. And this will not be the implemented design, knowing the way things are going, unless we find some other funding sources. No, this is not at the point.
It's a half.
Well, I mean, we were looking at designs like this. It was 2 million under, right?
yeah, depending on how many skates we fish,
Yeah.
this design could be 2 million under.
So, it's the design based on what we've assessed.
So this
Yeah.
design is not economically feasible and we might not even get bids if it were. So this is pretty hypothetical.
We might get bids. We put these things out to tender in the last couple of years. We got bids on some of these. We didn't accept all the bids. Some of them were just not the things we could, far in excess of what we were budgeting. For example, I think the Western Lucians, we may have got a bid last year or the year before, but we just couldn't
couldn't do it.
work with that bid, yeah. So, yeah, so what I'm presenting you today is what we feel we need to meet our scientific goals. And whether those are goals you may want to consider modifying, but those are the goals, the CV targets and reducing the risk of bias. And these are the designs that have been forward. These will almost certainly be modified when we start to consider secondary considerations of revenue neutrality. So I'll proceed on. I think this is going to lead into some interesting discussion on how we can get your input into that.
Yeah, because I mean, at this point, it's hard for us to say, well, you don't need 4A, 4B at this point, because we still continue to believe you do at some point. You know, even if it's like, well, you know, you don't have to do it every year, but you might not even get a bid.
But previously, our approach has been that we feel it's important to show them what we think we need, even if we know we can't have it.
Yeah.
Because we need to have a record of where the starting point was.
These areas in aggregate, these three, well, maybe including area 4 as well, there's something like 35% of the stock at some point. It's not a trivial amount of the halibut stock that we'd be not sampling if we don't sample there. And so if trends are unknown in these areas, then we're not sampling them. There's a chance of meaningful bias, especially as time goes on and we haven't sampled them for a number of years. So in any case, the designs that we propose would meet the coefficient of variance target ranges. Can't do anything about 2023 now, so slightly over, projecting to be slightly over in 4B for 2023. But once we if we were to implement that design in 2024, we'd be well under the target, which of course implies we could have a reduced design and still be under the target within that target. So there's something in between this design and nothing that would still keep us under the targets.
Or even over. I mean, it's, you know, 15% is
Right.
20% is better than nothing.
Right, and if you don't fish it,
Pull it off.
20% is what we're going to get. 20% is basically the CV one or 2 years out if you stop fishing. And if you do it, and if you fish another year, it starts to increase to 27, 20, 30%. And so you can have nothing, and if you set your goal at 20%, you'll probably get that. But then you've got next year, you're doing possibly very little, and it's going to creep up.
So Ray, these are the CVs. It's 2026, right after the sample completed.
Yes.
2026. What does the CV look like for 4B next year?
There is.
I mean, for 4B before that 2024 sampling gets done. It must be a lot higher than 16, right?
I'm sorry. You mean if we didn't sample in 2024?
Before the 2024 sampling is done, we don't know what's going to happen in 2024. Before that sampling is done, the CV in 2023.
You mean were we to fit space-time models before the data come in for the 2024 survey?
Exactly.
So that would be essentially
This fall,
16.
after this survey.
Oh,
before the
okay.
next-
Oh, okay. Well, that's what the 2023 column is. That is the 16%.
Well, I thought that was once you've gotten all the 2024, 25.
Oh, I apologize. You're absolutely right. It is. It is. Yes, and you're right. That would come down. With the 24 data would bring that down. Yes, I see what you're saying. That's what we'd be projecting in 2023 at the end of the 23. Yeah, okay. That's not a projection I've done. It's something I work out once we do once we get the data in. But yeah, you're right. It would be,
To a lot higher than that.
I mean, no, it's not going to be a lot higher, but it's going to get closer it's going to, probably all three areas will be above 15%. And somewhere between 50 and 20, I imagine maybe in the low 20s. Will be.
I mean, I would guess it has to be in the low 20s, right? Because this is assuming that you, following year, you do a ton of sampling out there.
It is, yeah. So let's to get a better sense. Okay, I'm. Let's see.
So I guess what I'm getting at is that the 4B CV this year is going to be pretty high.
Actually, you're right. It's going to have to be in the 20s, because the CV in 2022 for 4B was 19%. So we're already almost there, right? So, and then we're doing nothing this year, so it's probably going to be. It could well be in 25, 27%. Just looking at how these things have projected them to increase.
Right. So I think that's critical to understand. That this is really erosing.
It is. So it's a picture. It's like, yeah, we do all this great work and get this great data. We're back on track. That's what this is trying to say. But I really need to show, well, what if we do nothing? How far off track do we get?
Or even what our interim situation is before we do all that great work.
Right?
Yep.
And
our interim situation is quite high CVs and 4B.
That's a good point. And that's something I haven't done, because I know in 3 months I'm going to have that information directly. But it's worth projecting it, because the commissioners will get a chance to see that before the data. Okay, so yeah.
I mean, that is the consequence of their decision not to
Exactly.
something like the design that proposed and we endorsed.
That's true, and that's what they'll be working with to make their management decisions.
So
It shows that we're losing precision.
Is that something you can incorporate into the assessment?
Well, no, we'll incorporate the actual CV after the survey is done. We'll have that information. So this is sort of like a prediction of the consequences, and then we'll have the actual consequences in the fall after the survey is concluded. For 4B, it's the same thing, because we're not sampling anything. But for all the other areas, we're going to get at least a little bit of information.
But of course, for the assessment, it's aggregated coastwide.
Well, it's coastwide, but then it's the areas as fleets models we'll use for 4B.
Would be as a separate.
We'll have a CV of whatever it turns out to be, 20-something%.
Okay, so the bias assessment is a new thing this year. We presented it to you. I presented it to you in September last year. I think 21. Yes. So we proposed a new method for assessing bias potential based on probabilities of large change estimated from the space-time model. And here everything's focused at the sub-area level. As I mentioned, we've broken each of those 3 areas at the ends of the stock into essentially 3 sub-areas. And the idea behind this is that if there's a large change going on in some of these sub-areas, we want to be able to see it. So if whatever period that change is taking place, we need to sample frequently enough that we're not going to miss a change of that size. And here, large, we've had some discussion about this before, means a region within a reg area, sub-area, changes by at least 10% in terms of absolute biomass proportion within a specified number of years. Now, the number of years of most interest is the time elapsed since the region was last sampled. So we applied this approach to 2A, 4A, and 4B, where there's a risk of bias due to not all regions being sampled annually. And the results of the analysis informed our choice of the designs shown previously. And I mentioned in the report, and I've discussed previously, why this 10% value is selected. If you choose a value that's larger than 10%, say 20%, then in order to, that's the kind of large value that could have quite an impact on your estimates if you're not seeing a 20% change. And so we want to see, so you could have quite a large amount of bias if you have a 20% change and then you're not seeing. If you get down to 5%, then you have to sample extremely frequently And that's just not realistic. And 5% doesn't result in a large bias when you work things out at the regulatory area level. Okay, so these are maps that I wish I'd put in the report, but I don't really have them in a pretty form. These are taken from past presentations showing you where the sub areas actually are that we're talking about here. So IPHC regulatory area 2A, sub area 1 is recommended for annual sampling. That is the core of the 2A stock in central northern Washington, central Oregon. They're not contiguous, they're two parts, two separate pieces. But if we don't sample those annually, then we don't maintain CVs within the target range. Sub-areas 2 and 3 were last comprehensively sampled in 2017 and partially sampled in 2018 to 2019. So it's been a number of years since we've sampled those. And here in this figure, I'm working with a 7-year assumption, where most of it was last sampled 7 years ago. So let's talk, and sub-area 2 is the central part between Washington and Oregon, between parts of sub-area 1, and the main part of the stock in Northern California. Sub-area 3 is everything that doesn't have a blob drawn around it. So the deep and shallow waters, the Salish Sea, and the southern part of Northern California. So what are these figures showing? This is the risk, the probability, I guess, in terms of percentage, of at least a 10% change in the biomass proportion of each sub-area in the last 7 years. So if we're looking at, say, 2022, it's since, where are we, 2015. Okay, what's the chance that we've had a change of at least 10% in this sub-area's share of the proportion of the biomass from 2017 to 2022. We can go back through the entire time series and see how this change varies, but we're most interested in the most recent years. This is most relevant to what we're doing now, particularly if we haven't been sampling one of these sub-areas. If we have been sampling it, as we have sub-area 1 throughout much of the time series, then this probability is driven by what we actually observed, as well as some uncertainty. So you get high values for this, the more uncertainty there is, but you also get higher values if you've got a strong signal that's showing there is a large change. In the absence of any data, it's being driven by the uncertainty and also what's going on in other sub-areas. If one area is going up and you're monitoring that one, then the other area's proportions may well be going down as well. We don't know. Okay, so so here where the focus is on sub-areas 2 and 3, which mostly haven't been sampled since 2017. In particular, sub-area 2, in recent years, we've got a high risk of having a change of at least 10% in the share of the proportion of the biomass over a 7-year period in recent years. And that, I actually give the numbers themselves in the report, but it looks to be in the order of between 50 and 60% chance. That's a very high risk that there's been some change in this area in terms of how much the biomass is comprised of this sub-area, and we haven't seen it. We haven't seen that change. Whereas the risk in sub-area 3 is really low in recent years. That's because we sampled it in 2017, found it actually had very little biomass there. And so there's quite a low probability that that's been a large change in that part of the stock over 7 years. Okay, so this is what's driven, this is the driver for sampling sub-area 2 in 2024 and for sampling it in 2023 as well. There's a high risk that something's going on there and we're not seeing it. There we go. Okay, likewise in 4A, sub-area 1 is recommended for annual sampling. Again, it's the core of the stock. We need it to maintain CVs below 15%. And there's a high risk of large change over a short time period in this sub-area. It's basically been driving the trend for a number of years in 4A. Sub-areas 2 and 3 were last sampled in 2019. There's actually a fourth sub-area in 4A, and I don't pay any attention to it because it's very small. And that is where annual sampling from the NIMS Troll Survey occurs. And so we are getting some data for this tiny component of 4A. So Again, this is really 3 sub-areas of interest. Sub-area 1 has been quite changeable over time and has a very high risk of changing by a large amount in terms of biomass propulsion. And we're monitoring it. We monitored it in 2021. We monitored it in 2022. We want to keep doing that. The sub-area 2, which is the southern area here, which I hadn't initially proposed for sampling until 2025, it's also showing a very high risk of having a large biomass change over the last 5 years since it was last sampled in 2019. And that's an increasing risk as time goes on, as we have less and less certainty what's going on there since we sampled in 2019. So there's a little bit of signal coming from neighboring stations in 3B and sub-area 1, maybe a little bit of a troll survey, but most of this is likely driven by the increasing uncertainty we have of what's going on in this area due to not sampling it for in 2024 would be 5 years. Whereas we have quite low risk in sub-area 3. We last sampled in 2019. That seems good enough. The risk is increasing, but it's not a concern for now. And sub-area 4 is just tiny, and it's probably never going to be much of the biomass in 4A. So this is what's motivating the switch to bring this part of 4A forward to 2024 sampling and moving sub-area 3 back to 2025. And it may be that we reevaluate that and find that we don't. Then we can push sub-area 3 back further, but we can deal with that in later years as more data come in. So that's a high risk. That's a low risk. Sample in 2024, sample in 2025. 4B, sub-area 3, which is this, I went from west to east. Kind of wish I'd call this sub-area 1 now because this is essentially the core of the stock in 4B. We need this to maintain CVs of less than 50%, although it was last year the proposal was to sample sub-areas 1 and 2, which would also maintain the CV below 15%. Unfortunately, we weren't able to get a viable bid for sub-area 1, which is why the CVs went above 15%. So we can do this. We don't need, that's why I say near annual sampling. We can do this, skip this every 3rd year if we're sampling both of these areas together. Okay, so we want to sample this to maintain the CVs. This is it down the bottom here. This is over a 5-year period, but we're not proposing that for sub-area 3. We're proposing this for near annual sampling. This figure is graded for sub-area 1. We sampled sub-area 2 last year. We don't need to sample it again. The risk of large change, but the risk of a large change for sub-area 1 is increasing. And it's getting in the order of 30% or more if you check the report. So I call that a moderate risk. So it's an area that we would like to sample as soon as possible. And I proposed it for sampling in 2024 again. It was last sampled in 2019. Now, if we're prioritizing things for next year and we're looking for areas this is where this is helpful also in our meeting our secondary objectives. We're looking for which areas if we need to save money, where do we save money first? This would probably be the area we're saving money first. It's a moderate risk, but there are areas of higher priority because they have a higher risk of having a change. So this is quite useful. This analysis, I'm thinking, is quite useful in bringing the secondary considerations of revenue.
Is there the risk here is they're in isolation. So what you're saying is moderate risk in 2A and 4B. As far as the impact of the overall assessment and TCUI distribution and that stuff, they may have different levels of risk.
They may. I'm talking, the risk is in terms of understanding the trends in these areas or getting a good estimate of the proportion of the coastwide stock that's in each of these areas. If this is an area that's changed a lot in the past, you can see in the past when we had data, it was almost certain that we were changing by large amounts each year, or high risk, a high chance that would happen because we saw it most of the time. And so if things are changing here and we're not seeing it, then there's a risk of bias and that our estimates of the trend in 4B, and therefore its estimates of our understanding of its proportion of the overall coastwide biomass may be biased. But you're right, at a coastwide level, the risks are different. The slope assessment risks are different. And there was a comment or discussion earlier in the meeting about stock distribution and our estimates of stock distribution, and Ian pointed out the importance of these things, even if we're doing a coastwide assessment, we're still managing it at regulatory level. We need a good understanding of the proportion of biomass in each part of the stock. The CVs for those proportions are almost the same as the CVs for the indices themselves. It's just the index divided by the sum of the indices, basically, with the bottom area calculation. And so they're within 1 or 2% of the CVs for that. So if we're ensuring precision based on the indices, we're also ensuring precise values for the estimates of the stock distribution as well.
I think given the history of this, we would need a directive from the commission to relax that. That's not a choice we could sort of make on the fly and say, well, scientifically the assessment will be fine, so we're going to 20%, because it's really a policy choice to be using stock distribution as part of the management procedure or not. And that's a choice that's not sitting with us currently.
It's a policy choice that they already made, the design they chose.
Well, in some regards, yes. For 4B, there will be no precise information next year for stock distribution. Yeah. But we haven't been told to relax those CV targets in the context of we don't care about stock distribution to that level.
It just seems like maybe our job here at the SRB is to help make that policy choice explicit. For, asking you essentially to run the analysis for the situation in which the 2024 design that you're proposing here doesn't get done. So if they decide to cut all of that sampling that you've added to 4A and 4B, what then would the CVs be? And essentially show that they've got a stark choice here. Either they stick to that desired 15% CV and do that really expensive sampling out there, or they cut it. Yeah, you're not going to be able to cut it and still achieve those CVs.
Yeah. And it's something I can now that this is the path we're down, where we look at a lot of different designs the commissions consider. Media designs, running this analysis for it's just a day's work, day's model run. So it should be part of what we now present to the commissioners when they propose alternative designs. I'm thinking that each time there's a design, we can run this and we can put a CV on those designs as well. At least for the ends of the stock. If it was to do all areas, that would be a different story. But for these 3 areas, that's doable. And I will, and I know that because I did it on Monday, and I'll talk about why. So these were the projected CVs. This is basically, so when we're estimating CVs, we're using samples from the posterior predictive distribution based on the most recent modeling as a surrogate for actual data. We don't have any data for coming years, so we use samples from the most recent model which we expect to capture the variability in actual observations. Now, it's been discussed before at the SRB, and Sean brought it up in some pre-meeting comments that this is something we need to evaluate. What if there's a possibility that we're missing some unmodeled process, some source of variation that the process isn't capturing, that we'll see when the data comes. So we're comparing the projected CVs with what we estimate. And until last year, these were essentially the same values. Last year, and this year to a lesser degree, or they're not. So this is what we projected for 2022 CVs based on what we assumed was going to be the 2022 sampling design. We thought we'd have CVs of 14% for 2A, 10% for 4A, and 14% for 4B. So taking 2A first, in 2021, we had higher spatial variability than we had in recent years. And this pushed the CV up. Redoing the analysis in 2022 with the 2022 data, that was either a one-off or it was just, it's not something we saw in the 2022 data. It went back to the levels of variability that we'd seen in past years. And so that smoothed that effect out. And now we're closer to the projection than we were previously. So that whatever happened in 2021 is playing its way through these analyses. And we expect that unless something else is going on, that will continue to get closer to projections, everything else being equal. So it did look like there was something that the model hadn't been taking into account in 2021. But now it is nowhere close. It will be expected to be closer. So, but 4A and 4B were different. There were areas where not all sampling stations that we had planned in 2021 were completed due to logistical issues. And this was not accounted for in the 2022 projections. And the Western region in 4B was proposed but not sampled in 2022. So we didn't get CVs that were, what we actually observed, 14%, 90%, were quite a bit higher than what we had projected for 4A and 4B. Now, Sean speculated that maybe it's not just due to reductions in sampling, but maybe there's also something else going on. So I went and refitted on Monday the models with the actual design, the projections with the actual designs that were implemented in 2021 and 2022. In 2021 to redo essentially the projections for 2022. If we had known exactly what we were going to fish in 2021, what would the projections for 2022 have looked like? And so the CV for 4A would have been not 10%, but it would have been 13%. Essentially the same as the 14% that we actually observed. In 4B, if we had known in advance what the design was going to be, what the implemented design was going to be, the CV would have been 19%, exactly the same as what we projected. So my takeaway from that is it was because the reductions in sampling that we didn't get the CVs and that we were projecting. So again, that suggests that this is an exercise that, this year, I'm hoping that we're not going to have unexpected changes in the survey. I think it's pretty much going to scale back and those logistical issues to the degree that it's going to be in the logistic issues that came up in 2021 that weren't repeated in these areas in 2022. Other things happened in other areas, but we don't anticipate that to be a problem this year. And I haven't heard of anything happening so far that's causing concern. Again, it's a projection I can redo prior to the September meeting. If we seem to have departures from the implemented design, I can represent this at the September meeting with a revision. But if there's no departures, then we'd expect it to be like this. Okay, so we already have some incorporation of cost using logistically efficient sub-area designs. This is funded by sales of captured fish and is tended to have long-term revenue neutrality. So factors that may also be evaluated in the designs, expected catch of Pacific halibut, sales price, charter vessel costs, bait costs, and secretariat costs. In recent years, balancing these factors has resulted in modifications to the design proposals, increasing sampling effort in high-density regions and decreasing effort in low-density regions. At the last interim meeting, the Secretariat staff presented a sequence of designs with varying costs, ranging from the science-based proposal, the ones I present to you in June at this meeting, to a revenue-neutral option. Oh, this looks like the same slide with extra stuff. Let's see. It is, okay. The selected design balanced the primary science objective with the secondary objective selected by the commission of long-term revenue neutrality by greatly reducing sampling outside the core areas of the stock. Such sampling reductions have implications for the quality of resulting estimates, particularly if reductions continue over multiple years. And well, yeah, as noted, one way of emphasizing that is to present the CVs for any designs that we are under discussion by the commissioners. So, so there's some discussion about how we may make the designs that we do propose more efficient. Are there some ways we can save money while having essentially the same footprint, all other things being equal? And yeah, I'm not sure how much, but these are for your discussion, for your input. If you have any concerns about what's being presented for the, I guess, words of support or of what's being presented in the coming slides, then they will be welcome. I think they would perhaps help the commissioners in possibly refining a design or feeling comfortable with modifications to the types of designs that we're using now. So we have randomized station in the selection in the core areas, and it may not be the most operationally efficient design. We have the potential to fish just 1 or 2 stations per day when stations are isolated, when up to 4 stations per day can be fished. A large amount of the cost is just getting to the place where you're fishing the stations. If you can fish 4 stations in that day and doing that and it being out there for a day or 2 days or 3 days, if you can, the more you can do in a day, the more efficient the operation, the less cost it will have. So, however, it took me a bit of work to find one of these isolated stations in the randomized design. We're sampling at a rate of over 50%, even in this randomized design, which I know we have not been implementing in the last couple of years because we've been fishing near 100% of stations in order to cover the cost of the expensive part of the survey or to make it revenue neutral. So here's one. I found this one. So here's one that you would probably have to fish by itself, right? In 2C. And 2C is probably one of the more likely areas you'll find an isolated station. Otherwise, the randomized design tends to throw things up relatively close together. You can generally find 3 or 4 stations together you can fish in a single day. The inside waters may be a little trickier. And I'll come back to that in a moment. But this randomized design, which we generally haven't been fishing much of, it's not terrible in terms of efficiency, as far as I can see. But here's a couple of other options, which you've seen before. 2 other designs we've discussed in the past. Fish entire fish charter regions in the core area, rotating which ones we selected every year. It becomes a sub-area design, and we presented this in 2019, and nobody liked it. And it's what we do in the ends of the stock, and it's essentially what we're doing in 3A in 2023. But maybe we can drop a couple of charter regions, and so we have a compact design. We don't need everything to get precise information, and we don't need everything every year to get precise information. We can have a couple of gaps in coverage, and we still get information from last year. We'll have information next year. We get information from adjacent stations, and it becomes perhaps a more efficient design. Another possibility that I've discussed and it's gone nowhere is sampling clusters of stations. So set a minimum number of stations of 3 or 4 that you can fish in a day, and so you randomly select clusters of 3 or 4 stations, and so you get a patchier looking design. But over a 2-year period, you'll be at this high sample rate, you'll be fishing everything. Now, nobody wants to do this at the ends of the stock, so this is not really a serious consideration for those because it's really, as I mentioned, it's really expensive to get there. You get there, you might as well do these 3 extra stations on Ballard's Ridge, and like we did in 2022, and you can save a lot of money by skipping those. But in the core of the stock, in years where we have relatively high catch rates and we don't need to offset the cost of the survey by increasing station density, this seems like a good design. I've mentioned this at research advisory boards almost every year. I brought it up a couple of times at the SRB. It never goes anywhere. But I I guess I or the commissioners in particular may be interested in your thoughts, at least from a scientific perspective, on any pros and cons you see to implementing designs like this, if this were to save us some money. I think in the current world we live in of high costs and relatively low revenue, we were fishing close to 100% of what makes money. We're not going to get a lot out of this by switching to these types of designs. And we're de facto doing this in this design on the left in the core of the stock anyway. There is one more thing. Let's see if it shows up here.
Okay, can you
Yeah.
just summarize what the argument has been against the cluster design? I don't know this.
No, I don't think there's been one. I just don't think anyone's run with it. You know, I could take it up myself, but I personally, randomized sampling is usually what I'd like to do. So I don't have any lack of enthusiasm for this, but nobody's had enough enthusiasm where they said, yes, let's do this. And certainly no one's tried to cost it out. I don't know what we save by doing this compared to even a randomized design. Probably not a lot, given
Very
that
little.
very little. Because you can, even the randomized design, unless we're going down to like, if we're talking a randomized design with sampling rate of 20%, yeah. But we're looking at 50-something% in those areas. And so you generally can find 3 or 4 stations. We hear more about fishing aid skates than we do about isolated stations.
The hope would be that this would encourage people to make lower bids because they would like to fish this design
Right.
better than a randomized design where they have more running time to get to their stations. But the reality is we've not seen.
The only real test of it is if we put both designs out there to bid.
Let
And
them bid on both.
They let them
Yeah.
bid on both, and we find somebody picked this one and it was lower than. So
And we've actually asked about that and informally been told they wouldn't do it. They wouldn't bid on both. They just bid on the one they wanted.
They wouldn't actually give you the information about the cost differential. For the-
Well, it's a competitive process and they're competing against each other and in some degree against us. So, right, to make money on the bids. So it's a challenging situation. You know, we're always trying to work with the boats to make them willing to bid lower because make the work look more appealing, but yet at the same time, it's still a competitive bidding process. If there's only one boat that's willing to bid on a certain area, either take it or leave it.
I guess just picking this, if they pick this design, that presumably means they think they're going to save some money. Whether they pass that along to us. Yeah. There is one other.
Any commercial, like fish commercial wild inventory?
No, but that's something, actually, Claude and I were just talking about that. It's something that we have discussed as a potential option would be to allow some fishing, some commercial fishing during the survey period. Would require keeping the fish separate and some other logistical challenges. But that might be a thing to consider.
There's a history to that.
There's risk to it though, stop on a commercial vessel that's no longer on contract.
So there's some liability issues we have to explore. Yeah, we could potentially look into it, but there's risk there.
There's also a delicate balance. I mean, we allow the vessel to keep 10% of the proceeds of the catch so that they have skin in the game, but not 100% because we don't want them to be gaming the system. And so there's a fine line. I think it was in Claude's era when he was running the survey that they sort of found that 10% was a reasonable compromise between those things. And so throwing in now, well, if we just get this survey stuff done, we can go catch quota the rest of the afternoon, could add a new element that we probably want to be careful thinking about.
Right. So we're inviting your comment on alternative design options or something else. And we also note that we have suggested that isolated stations where they exist can be avoided by adding extra stations nearby. And this was done annually in Area 2C, the inside waters. We would have had some isolated stations in the pre 2020 design, but extra stations were added so that they would fishing 2 to 3 stations a day at least. and they were added in the 2B during the 2018 expansion. That's not an option that's been taken up by this team, and I guess it's not been pushed by the folks bidding on this, if they're even aware that this is something they can do. But avoiding isolated stations is not a difficult thing. There's a very simple. There aren't that many of them. We can do something like this. It's extra data. It's not going to hurt.
And how do these, like, for example, the two that you showed, the cluster and the sub area, they affect the quality of the space-time model? That's
Sorry if we were fishing the cluster design.
like the two that you showed there.
Yeah. So we would.
Quality of the space-time model.
I think, but this one I don't think it would have any noticeable
Looks like
effect.
it's probably better, right?
This one would be better because we have comprehensive spatial coverage, and over a 2-year period, we have everything signed. Because if the next year we're fishing the ones that we didn't fish, and maybe a little extra because we're sampling at 50%. Assuming that's what I assumed in this case. So we'd have excellent information spatially and temporally, and the spatial strength of the spatial dependence is typically in most areas out to 30 nautical miles. So you're getting information out into those gaps from the data that you're actually getting each year. This, there's no information here. There's nothing informing this Western Aleutians in this design other than what we've got in that area in the past. And general covariate relationships, the relationship with depth, I fit an overall trend. So it tends to rise and fall with whatever is going on. We did fish, but no direct information. So this is I like this design better. It's just one step removed from a completely randomized design. But over again, if we were in terms of the core of the stock, we're doing this anyway here, and this isn't viable in the ends of the stock. In terms of the core of the stock, this is still fine. If we're fishing this, if we fished this design in 2021 and then 2022, we mop up the areas that we didn't fish and we skip some other areas, we're still getting really good information. We're still nailing down that signal on what the trend is and what the spatial patterns are in the stock. So neither are bad. This statistically is better. This would give more precise estimates in general I mentioned on an annual basis, particularly for the terminal year of the series. Okay, good. Yep, so recommendations that you paper, endorse or not the 2024 design proposal and provisionally endorse the 25-26 designs. But in general, of course, we're looking for your comments, your feedback, your insights into how we move forward with these designs, given that we are unlikely to be implementing at least the 24 design, the 2024 design as proposed at this meeting.
It seems like there's kind of this slow motion train wreck happening with 4B.
Yeah.
When you miss it this year, for whatever reasons, they change the design of bids, then it piles on additional sampling requirements the next year, which makes that a complete non-starter for cost perspective. So you've kind of built up to this situation where it's increasingly important and increasingly not viable.
Yeah.
From a cost perspective.
And in 2021, as Ray noted, we didn't get all the stations we wanted out there. We had a bid, and the vessel worked with our survey team and said, I can't do them all. And we said, okay, start at this end and do as many as you can. And we got something was better than nothing. We didn't get all the stations.
Unfortunately, I don't think we told them which end to start at in 2021. We learned from 2021 and told them which end to start at in 2022 because they started at the wrong end, and that wasn't their fault, and we didn't give them directions. We just assumed they were going to complete it. So they started in the lowest density area and then get to the highest density part, and the same thing happened for it. So we learned from that. Now we give clear directions. If in case something like that happens, we prioritized a fishing direction.
That happened in Shelikoff or Portlock last year.
Yeah.
We did tell
Right.
them which end to
That's
start
right.
at.
So, yeah, you're right. It quickly, the CVs blow up quite quickly. 1 year, we lost data in 2020 because of COVID. We didn't have any sampling there, but we got back on track in 2021. But when you start to get 2-3 years, I did look at this a few years ago for 4A. If we, as an example area, what happens if we don't sample for a few years and the CV starts to blow up? You need, so so the path forward isn't going to be, okay, we don't sample it in 2023 and we miss it in 24, so we're going to have to do every station in 2025. That's not going to happen. We're going to have to, again, prioritize the bits, do what we can, and eventually we come back and it'll be this part of the time series that has high CVs forever. And we'll always have uncertainty about what was really going on.
Yeah, and it seems like also part of the optimization has to consider the realities of what's appealing to the industry because of that issue with putting out a design that nobody wanted to bid on. It's too few stations to be worth driving out there.
Right. Yeah, and that's something we can discuss again with the commissioners if that comes up. That you know, it seems that people will bid on designs in these far-flung areas, but they're going to be really expensive. So I don't know what a minimum looks like for
So your space-time model allows you to not have to rely on a 10 nautical mile grid, right? You could come up with a completely new station layout that gives them some efficiency of day. Maybe it's, I don't know, a 6 mile layout or something in clusters. Just rethinking it completely because your space time allows you to have more freedom with your geography in a sense.
Yes, so we could fish we're going to fish 50 stations. We can fish them over a smaller spatial footprint.
We did that in Northern 2A in 2017.
We did exactly that in 2A in 2017, and they fished other designs in the past, like stratified designs in 2A and denser designs in 4C at one point in the 90s. And the space-time model handles all of that.
What is old is new again, huh?
Right, but there is a diminishing returns to densifying the grid, right? I mean, especially when we see that the spatial dependence is not at really fine scales. We have the denser grid and the rock stations in 2A. It's out to 30 nautical miles, so you don't gain a lot by adding a whole bunch of extra stations close to the station you're going to fish.
I guess where I was going with it is, what are the biggest financial drivers that are on the other side of it? So setting aside the scientific, there's bait and there's fuel from the vessel's perspective. They don't care about the bait. The budget side here does.
Okay.
But if you can optimize their fuel in some sort of manner to make it more attractive, you may be able to drive down that cost.
So, right, I see where you're getting. So if the commission has proposed a design like the one they did in 2023, there are just 32 stations on the 4B, 4A edge, we could make that more appealing by increasing this, totally changing the grid and making it more dense. And, if it's now a 50 or 60, say a 50 station grid, we might get a bid on that. I don't, Ian does the costs and most of the cost is per station, right? I don't know how much you'd be able to factor in reduced running time into the process through lower station density.
I don't know that we really know how the vessels themselves may not even be really factoring that in. It may be just kind of ballpark when they put bids together.
And the other approach is to increase the revenue side, which room do you have to just put a whole bunch more stations or areas where they're making money?
So we do that already. As you saw, we went from a 52% sampling rate, random sampling rate, to 100% in the money-making areas. But at some point, our tertiary goal kicks in, which is
not to take too much out of the stock, both coast-wide and in a particular area. So we do get pushback on the amount of fish we're removing from the most productive areas from the survey. We currently keep the survey under, I think, 3 or 4% of the total landings is coming from the survey. It's still a very small piece. But if we were to take, say, 50% of the catch in a regulatory area on the survey, that would be a non-starter. So there's a gradation there.
I mean, it seems like it'd be helpful to have some scenarios where, you know, if you really want to maintain 15% CV, or that ship has sailed. If you want to stay under a 20% CV or whatever it is now at this point, you're either going to have to surveys you're not going to be revenue neutral, and this is what it's going to cost, or to make it revenue neutral, you're going to have to take this much of the core entities. To make those trade-offs really clear. My guess is that with this many variables in a 4-factor optimization, it's really hard for them to make clear decisions about this and to really understand the implications.
You say close to 4, and Ray, I know you have to duck out by
yeah.
4. I have a meeting as well at 4. And you have probably not an hour or so of drafting left. We do have the simulation tool, which will show you some of these examples, but I'm thinking it'd be better to leave that till tomorrow morning at this point. That way you can have the next hour to sort of draft up everything prior to the FIS discussion, have to think about what Ray's presented, and then tomorrow morning we can run through the simulator and talk a little bit more about some alternative designs. That would be agreeable.
Stepping you through the design process, how we start there and end up at revenue neutral would be helpful.
Okay. Thank you, Ray. And that'll be it for today. And then we'll have a adapting session.
Do it. What time would you like to start? 9:30 again tomorrow? Or if you need more time, it's no problem. Just let us know in the morning. Just target 9:30.
Let's just say 9:30 unless otherwise.
Perfect. All right. Thank you, everybody online. We'll see you at 9:30.